Hi, 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 hi. Hello, hello, hello.
This is all good, right?
Hi, 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 hi. Hello, hello, hello. Hello, hello.
Right. So, what is the problem?
Hello, hello, hello. Hi, hello, hello.
Thank you so much. Okay. Am I audible now? అందరికి ఒకసారి చెప్పండి. Everything clear? Everything clear? Everything clear? No. No, I'm from Bangalore. Bangalore. Okay, not Tirupati. చెప్పండి అందరికి. Is my voice clear? Is my audio video all clear? All clear? అంతా క్లియర్గా? Right. Tell me. Is everything clear? Can we shift to the chapter? Good morning, good morning, good morning, all of you. Good morning. Very good morning, very good morning, very good morning. So, can we switch to the chapter, all of you? Chapandi okasari. Hey, what is going on? Very low. Voice is very low. Don't know, sir. The reason behind that actually. Hi, hi, hi. Hello, 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 hello. How should I increase the voice? I can't increase it. Hi, 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 hi. Am I audible now? Is it clear? Is it clear? Everything clear, Andariki? Hello, 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 hello. Hey, tell me, all of you. Is it clear? Is it clear now? Not clear. Clear, not clear. అందరికి చెప్పండి ఒకసారి. Hi, 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 hi. Am I audible now? Everything clear? Hi, 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 hi. Everything clear? Hi, hi, hi. Hey, what are you telling? I can hear my voice in my own device, So it's clearly audible. What's the problem you guys are facing? Hey, what are you telling? I can hear my voice in my. Okay. Yeah. So please adjust for this session, Please adjust for this session. ఎందుకంటే we don't have technical support for now. Sunday కదా. So not all the people they are aware of this. So good. So far so good. Let us adjust. Okay, let us adjust with it and start చేద్దాం అందరికి. Let us start with this topic. The name of the topic is magnetism లేదా you can call it magnetic effects of electric current. Okay, all of you tell me, చెప్పండి ఒకసారి. Right. Okay. I can't shout, you know. Done, done. Satvika, it will be uploaded today only, okay? I have recorded that. I have recorded that center of mass part 2. It will be uploaded on the channel, okay? చూసుకోండి ఈ లెక్చర్లో వీఆర్ గోనా స్టడీ అ వెరీ బ్యూటిఫుల్ రిలేషన్షిప్ బిట్వీన్ ఎలక్ట్రిసిటీ అండ్ మ్యాగ్నెటిజం. అంటే ఏంటి సార్? Yeah, I'm speaking high only, right? You can't hear me, all of you. Is my voice really not clear? Or I should change a few settings. I'm really not able to understand what's happening, you know. Hi. Am I audible, all of you? Is it clear now, all of you? Is it clear? Voice is clear? Not clear? Should I again speak fast, or it's okay, ra? ఓకే, చూద్దాం, అందరికీ చూసుకోండి. సో ఈ సెషన్లో వీఆర్ గోనా డిస్కస్ అబౌట్ ద మ్యాగ్నెటిక్ ఎఫెక్ట్స్ ఆఫ్ ఎలక్ట్రిక్ కరెంట్. అంటే ఏంటిరా? లెట్ us స్టార్ట్ విత్ అన్ ఎక్స్పెరిమెంట్. ఏం ఎక్స్పెరిమెంట్ చేయాలి సార్? యా, గుడ్ నందిని, వెరీ గుడ్. ఓకే, సో యూ లెట్ us ఇమాజిన్ దట్ ఇట్ ఈజ్ అ వైర్. వైర్ అంటే ఏంటిరా? వైర్ అంటే now we have to flow current through it, ray. Okay, we are having a wire, దీంట్లోంచి we are trying to flow current అంటే flow of charge, ఇదే కదా? yes, your normal electricity. ఇప్పుడు చూసుకో, I am taking a ball, normal ball, తెలుసా? small ball, metallic ball, small metallic ball. ఈ ball ని I am charging it. So let us say the charge on this ball is plus charge, okay, positive charge, plus q is the charge given on this ball. What I am doing now is I am actually bringing this positively charged ball close to the wire, here. As soon as I bring it, sir, ఏమైంది? Okay, what will happen as soon as I bring this charge close to this wire? Nothing will happen, okay, nothing will happen, Ray, nothing will happen, okay. But as soon as I gave Yes. So when I bring a charged object near a current carrying wire, nothing happens, ra. But as soon as I give it some speed, and you imagine, if a speed is given to this charge, let us say we are pushing this charge with a speed v, and hitting this charge, ra. What should happen, sir? When I am giving the speed, the charge should simply go straight forward, kada? Ledu. It did not happen. So what happened, re? In that instance, the charge went deflecting, something like this. Deflection happened. Deflection happened. Deflection happened. Why deflection, sir? Why did the charge deflect? For example, if you have a normal object, you push it, it will go in a straight way. Ante kada? Similarly, I had a charge. Okay, I gave it some speed, ray. I gave it some speed, and then it got deflected. Why this deflection came into the scenario? Ante kada? That is the reason that led for us to study this entire chapter, magnetic effects of electric current. Ardhamaindi? So what is the reason ante? You understand the reason, I am telling you. The reason is simple. A current creates a magnetic field. Ade entira, a current creates a magnetic field. Finished. Okay. So now let us talk about Oersted's experiment. What did he do? It is a normal circuit, proper battery, resistance and a circuit. What he did is he actually placed a magnetic needle. Andariki chuskondi. He placed a magnetic needle. Leda, you can simply say compass. And as soon as he turned on the switch, as soon as he turned on the switch, there was a deflection in the magnetic needle. Ante kada? So what that means, Ray? That simply means a current always produces a magnetic field around itself. So the current started something like this, and it is producing a magnetic field. Ante kada? Right. Next, first we will try to talk about finding the magnetic field. Okay, first we will try to talk about finding the magnetic field. Buffering. And as soon as he turned on the switch, everything clear, right? Everything is clear. Good. So, These are the two set of rules with which we will be calculating the magnetic field due to a current carrying wire. It will be covered, Satvik, I will cover right hand thumb rule directly into this Biot-Savart law, okay, you will understand. Okay. Okay. We'll discuss everything, we'll discuss. You don't need right hand thumb rule, okay, sorry, you just understand what I'm trying to say, okay. Once you understand, if you don't understand the concepts, then I'll explain you right hand thumb rule, but you understand for now, okay, you understand for now. Choose. Let us talk about the first rule, Ra. What is the first rule? Biot-Savart law. What does it say, Ra? Choose ko. To understand Biot-Savart law, you might have to understand a few terminologies, okay? You might have to understand a few terminologies. What are the terminologies, sir? This is my wire ray and it is having some current I. Choose kondi andariki. This is having some current I. Okay? So, sir, for sure that means it is creating a magnetic field around itself. Let us go from this to your right hand thumb rule, okay? For example, you understand. So, what does it say? If a wire is there and carrying some current I, Ra, the magnetic field at any distance, at any point, okay? Satvika, you understand, okay? You understand. You understand this, everything will be covered. You don't need those shortcuts, you know, all these things. No, you don't need that actually. You don't need that. I will explain you all the things very clearly into it. Okay, let us go a little high level and let us discuss high level things first. Okay, these all these things, what is going on, Ray? Not waste. You understand what I am telling you, okay? Yeah. Nice. Choose ko andariki. So, if some current I is flowing, Ra, choose ko. How many points do I have? Sir, it is a wire. For example, sir, this is my wire. Okay, this is my wire, Ra, choose kondi. This is my wire, kada? Yes, it is carrying some current, Ra, choose kondi. Ade kada, this wire is carrying some current. And how many points are there? Here is 1 point, here is 1 point, here is all there are some points, kada? Yes. You imagine the current is flowing in the upward direction, something like this. Okay, the current is moving in the upward direction. So you have to find the magnetic field at all these points. At what points? All points in space, Ra, all points. So a wire, this actually creates the magnetic field at each and every place in the space. Understanding? At each and every place in the space. How will you find the magnetic field? If magnetic field find cheyadaniki, we have this law, Biot-Savart law, very important, very important formula. Okasari you are good with this formula, you literally don't need any shortcut or anything, okay? I will explain you in such a way that all your concepts will get clear. Just the thing that I want from you is your attention, understanding. Good, చూసుకోండి. మొదటిగా ఫార్ములా రాస్తున్నాను, చూసుకోండి అందరికి. సో magnetic field, small magnetic field dB is given as mu naught I into dl bar cross r bar divided by 4 pi to r cube. R cube, Hey, before that you have to understand terminologies, Ra. Choose ko. Formula lo, there is some mu naught term, there is some I term, there is some dl bar term, okay? There is some r bar term. You understand these four terminologies, andariki. Cheppandi. Once you have idea of these four things, then you can easily go and calculate your magnetic field. Sir, what are the terminologies? Mu naught, gurtunda, in electrostatics we have permittivity, something epsilon naught. Here it is mu naught. Permeability, akkada permittivity, it is permeability. Permeability ante enti, sir? It also depends on the material. Okay, good, very good. What about I ray? Current through the wire. Now comes very important understandings. The first one is your DL bar and the second one is your R bar. DL bar ante entira? DL bar ante position vector. Chuskondi andariki. DL bar ante it is the position vector. DL bar is a position vector of what ray? Of what? Of what? DL bar is a position vector of the point at which interested to find magnetic field. Hey, not this ray. It should be actually R bar, okay? It should be R bar and DL bar should be something like this. Chapand. Now, with all that being said, okay, now with all that being said, let us directly analyze the formula and the applications. Choose andariki. So, okasari I do have my wire. What do I have to do? Step number one, all of you, you understand. Step number one, you cut a small length DL from this wire. Cut a small length DL from this wire. Ante this is my small length DL. Ide kada? Yes. What should be the direction of DL ray? Direction of the DL is equals to the direction of the current. Ante kada? Yes. So this current is flowing upward and automatically DL ki direction kuda upward vastundi. Ante kada? So ide na DL ki direction ochindi andariki. It is in the upward direction. Point number one. Point number two, DL is a small length of the wire. Ante. You understand. You got DL bar kada? Yes, you got it. Dan tarvata you understand about R bar. It is very important. It is chala important thing ra. Okay. Okay. Yes. Yes. Yes, Janvi, it only talks about the expression due to small current only, not about the large conductors. For large conductors, we have to use it and integrate it, depending upon the situation. Obviously, wire unte, where integration. Circular coil unte, where integration. It depends completely on the situation. Ante kada? Yes, DL bar direction is exactly the direction of the current. Point number one. Point number two, R bar ante position vector of the point at which we are interested to find the magnetic field. Ante, I want magnetic field here, sir, leda here, sir, here, sir, here, sir, outside, in the plane, wherever you want, you just draw the position vector. Sir, how to draw? Now you must be able to draw the position vector. Ela draw cheyalira? Chusko. Start from the tail of DL bar. What I am telling? Start from the tail of DL bar. Andariki cheppandi okasari. Start from the tail of DL bar and end at position vector. Ante let us imagine naku ee point pai magnetic field kavali, okay? I want the magnetic field at this point, andariki, at this point. So ee point lo kavalante you start from the tail. Start from the tail of DL bar. So ekkada unnara? Here is the tail of DL bar kada? Yes. So you start from here only. Cheppandi andariki. You start from the tail and you go to your position vector. Ide na R bar andariki chuskondi. Are you understanding? I am telling you just for the shortcut, okay? To make the things more clear, all the times whenever you are applying Biot-Savart law, take a small length DL on the wire, dan tarvata start from the tail of that DL and go to the desired point. Ante kada? Yes. So it became your R bar, it became your DL bar. Ippudu cross product of them. Cross product. Telusa, how do you do cross product? Hey, cross product ante you have this vector A bar and you have this vector b bar, how do you do it? Cheppandi andariki. So you take a bar cross b bar as right hand, take your four fingers in the direction of a bar, curl them into the direction of b bar. Ide kada? This is the direction of the cross product. Yes, 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 direction of the current. Okay, good. So you have to take the cross product. I can't help you if you don't understand what the cross product is. At least ఈ స్టేజ్ లో మీకు క్రాస్ ప్రొడక్ట్ గురించి కొంచెం ఐడియా ఉండాలిరా. ఓకే, సో స్టార్ట్. లెట్ us do the cross product of dl bar and r bar రా. చెప్పండి ఒక్కసారి డైరెక్షన్ చెప్పు అందరికి. dl bar cross r bar అంటే ఏంటి సార్? I first want dl bar అంటే all my four fingers in the direction of dl bar. ఎలా? How to do it, right? How to do it, sir? All my four fingers are in the direction of dl bar. Ide kada? Yes. Are you understanding? All my four fingers initially must be in the direction of dl bar. Dan tarvata curl them in the direction of r bar. Ante ide na dl bar. This is my r bar, right? It is the cross product. Ante kada? Yes. Where is the thumb pointing? Inside. Andariki chesko. Malli okkasari I want each and everyone to do it. Okay? I want each and everyone to do this question. Under this expression, okay? Okay, all of you tell me. Cheppandi andariki. So what should I do? Take my four fingers in the direction of dl bar and then cross them in the direction of r bar. Your thumb is going inside until the magnetic field at this point will be inside. Understanding? Understanding, not understanding. Okay, let us do some similar calculations for your this point also. Teeskondi andariki. So this becomes my dl bar. Ante kada? Small length dl bar. Andariki చూసుకోండి. Step number 1. What did you do? Step number 1. Take small length dl bar. దాని తర్వాత yes, very good, very good, very good. Kirtana, very good. దాని తర్వాత you join the tail. I will write the steps only. Step number 1. To apply your Biot-Savart law carefully, what do you do? Take a small length dl bar. Take a small length dl bar in the direction of current. Ante kada? Yes. Step number 2. Okay, step number 2. What is step 2, ra? Step number 2. Start from tail of dl bar. Start from tail of dl bar and join the vector pointing to the desired location. R bar ante R bar. This is R bar. Step 3 ra. Step 3 ante enti? Step 3, check the value and direction of dl bar cross r bar. Ide kada? Yes. These are the only 3 steps. Good morning, good morning, good morning all of you. Good morning, good morning. Okay? These are the only 3 steps that you will be checking. Okasari you are good with all these steps. You don't need any law here. You don't need left rule. You don't need right hand thumb rule. Nothing. You don't need anything. Okay? Understanding. So let us do some questions. Chuskondi andariki. So this is my current I. Andariki chuskondi. And I want the magnetic field at this point. Cheppandi. Ela cheyali ra? Ela cheyali? Hey, all of you tell me. Cheppandi andariki. Same step. Take a very small length dl. Ekkada tiyali sir? You can take anywhere. So I am taking my dl length as somewhere here. Chusko. So this is my dl length. Direction enti sir? Direction is the direction of current. Ante kada? Yes. So this is the direction of my dl bar. Andariki chuskondi. Step number 1 completed. Ante kada? Yeah, chuskora. Hey, step number 1. Take small length in the direction of current. Ade, small length in the direction of current. Finished. Step number 2. start from the tail of dl bar, join the vector to the desired location. Ante start from the tail of dl bar and join at the desired location. So ఇదే నా desired location అంతే కదా. So this vector will become r bar now. దాని తర్వాత step 3 రా, check the value of direction of dl bar cross r bar. ఎలా చెక్ చేయాలి? Now you must be good at finding the cross product of the vectors అంతే కదా. So how to find it? Take your 4 fingers in the direction of dl bar and curl them in the direction of r bar. Ide kada? Yes, you curl your 4 fingers in the direction of r bar. Ante the magnetic field at this point is coming out of the plane. Ade kada? Okay. The magnetic field is coming out of the plane. చూసుకోండి, ఐఎమ్ ఆల్సో రైటింగ్ ద డైరెక్షన్స్ అందరికి చెప్పండి. నంబర్ 1, ఇఫ్ కమింగ్ అవుట్ ఆఫ్ ద ప్లేన్, what do we represent it with? We represent it with dot and then circle. Number 2, going into the plane, we represent it with a cross and a circle. Okay, you must understand all these things. Are you even listening to me? Good. ఇప్పుడు ఫార్ములా చూద్దాం అందరికి. చెప్పండి. సో ఇఫ్ యూ హ్యావ్ అ వైర్ అండ్ అ కరెంట్ I is flowing through it, అందరికి let us imagine, hey all of you, let us imagine a small length dl ra. Okay, dl bar is a small length in the direction of current. You want the magnetic field at this point, and this becomes my position vector r bar. Ide kada formula enti ra? Formula simply states small magnetic field db bar is equals to mu naught into I into dl bar cross r bar divided by 4 pi into r square. R square or cube. Okay, yes. So sir, you can simply say dB is equals to magnitude గురించి మాట్లాడుతున్నాం చూసుకోండి అందరికి, mu naught I into dl into r into sin theta. ఇదే కదా? Yes, divided by 4 pi r square. అంటే r gone. ఇదే కదా? So your magnetic field magnitude will come something like this. It is equals to mu naught I into dl into sin theta divided by 4 pi r. Okay, should be r cube. అర్థమైంది అందరికీ? Good. So let us apply it. Let us apply it for some cases. Okay. If you want, I can do the entire derivation also, Kani, I want you to remember this derivation. Okay, I want you to remember this derivation. Case number 1, circular arc. Circular arc ante this is my circular arc. Ante here somewhere will be the center of this arc. చూసుకోండి అందరికి. ఈ యాంగిల్ అంటే తీటారా చూసుకో అందరికి, ఆల్ ఆఫ్ యూ. ఇట్స్ అ వెరీ ఇంపార్టెంట్ రిజల్ట్. ఓకే, ఇట్స్ అ వెరీ ఇంపార్టెంట్ రిజల్ట్. సో హౌ డు యూ డూ ఇట్ సార్? సేమ్ ప్రాసెస్ రా. సేమ్ ప్రాసెస్ అంటే ఏంటి? Take the step number 1. What step number 1 will you take? Take a small length dl in the direction of current. ఇదే కదా? Take a small vector in the direction of current. How do you take it, Ray? And what do you name it, Ray? So let us imagine this is my small vector dl bar in the direction of current. Next, step number 2. Cheppandi, step number 2. What is step number 2? Step number 2, row. Step number 2, row, you will have to join the tail. Okay, you will have to join the tail with the desired point. నాకు సెంటర్ లో మ్యాగ్నెటిక్ ఫీల్డ్ కావాలి కదా. ఎస్. సో ఈ కేసులో ఐ విల్ జాయిన్ ద టెయిల్ ఆఫ్ డిఎల్ బార్ విత్ ద డిజైర్డ్ లొకేషన్ అండ్ ఈ డిస్టెన్స్ ని ఐ విల్ కాల్ ఇట్ యాజ్ ఆర్ బార్. చెప్పండి. ఇప్పుడు ఐ వాంట్ ఆల్ ఆఫ్ యూ టు ఫైండ్ ద యాంగిల్ బిట్వీన్ డిఎల్ బార్ అండ్ ఆర్ బార్. అందరికి చెప్పండి ఒకసారి. ద యాంగిల్ బిట్వీన్ డిఎల్ బార్ అండ్ ఆర్ బార్. Angle between DL bar and R bar. Ante, sir, angle between DL bar and R bar. What is the angle? Just give me a minute, okay? All of you. I'll be back in a minute. చెప్పండి. Yes, so I've taken my DL bar kada, and this is my R bar andariki. The angle between DL bar and R bar is 90 degrees. ఎందుకంటే చూసుకోండి, it's a very small length, అంటే it's a tangential direction. Tangent to the circle kada, yes. Tangent unte, what is the angle between radius and tangent ra? So it is 90 degree angle. Understanding all of you, right? So angle between DL bar and R bar is equals to 90 degrees అంటే pi by 2. అండర్స్టాండింగ్ ఫార్ములా చెప్పండి సార్. స్మాల్ మ్యాగ్నెటిక్ ఫీల్డ్ dB bar is equals to mu naught I divided by 4 pi multiplied by dl bar cross r bar divided by, it should be r cube. చూసుకోండి, when it's r bar, when it is a unit vector, you can take r square. If it's not a unit vector, it's not unit vector అంటే you can simply take 1 by r cube. ఎందుకంటే you can write r bar by r is equals to r cap ante kada. Yes, my habit is I usually don't write this caps, okay, so you understand it. You can simply say, sir, this is the value of your small magnetic field, chinna magnetic field at the center, it is equals to mu naught I divided by 4 pi into, simplify dl bar cross r bar ante dl into r into sin theta, kani sin theta ante sin 90 kada, divided by r cube ra andariki. So idi r gone, sin 90 also 1 ante kada. So small magnetic field dB bar is equals to mu naught I divided by 4 pi multiplied by cheppandi dl by r square ante kada. Yes, what is dl, sir? dl is the small value, what small value? Small value of that length ante kada. So I want all these dl ఇక్కడ కూడా dl అంతే కదా. ఎస్, వాట్ టు డూ నౌ? ఏం చేయాలి? వన్ వే వీ కెన్ థింక్ ఈస్ టు డూ ఇంటిగ్రేషన్. కానీ దెర్ ఈస్ అ థింగ్ దట్ ఐ హ్యావ్ టు వెరిఫై. వాట్ ఇస్ ద థింగ్ రే? యూ కాంట్ ఇంటిగ్రేట్ ద వెక్టర్స్ ఇఫ్ దే ఆర్ ఇన్ ద ఆపోజిట్ ఆర్ డిఫరెంట్ డైరెక్షన్స్. అంటే ఏంటి రా సార్? చూసుకో, ఇఫ్ దిస్ ఈజ్ మై ఫస్ట్ వెక్టర్ ఇన్ ద రైట్ సైడ్, సెకండ్ వెక్టర్ రైట్ సైడ్, థర్డ్ వెక్టర్ రైట్ సైడ్, then I can add directly. Add ante integrate. Understanding? Add ante integrate. If my vectors are not in a one direction, ante these are my vectors ra, chusko, I can't integrate them ఎందుకంటే they are having opposite directions. So ఆ కోసం I must check the direction of magnetic field due to each and every dl. Understanding? So let us check 2-3 vectors. So I will taking dl in this direction ra, cheppandi. Sir, dl bar r bar outside, dl bar r bar outside. Every dl bar is giving me the magnetic field outside. Ante each and every magnetic field is in the outer side. Ante direction same untundi. So you can directly integrate it. Eppudu you can directly integrate it. Integrate cheyalante you have to integrate. Cheppandi andariki. So integral of db is b bar ide kada. Yes. Constant. R kuda constant ra. Why sir? R ante radius, not distance ra. R is the radius. Radius unte you can take it out. Bayatiki teeskondi andariki. So you can simply say mu naught I divided by 4 pi into r square integral of dl. ఇప్పుడు small చిన్న dl ని integrate చేయాలంటే what do you do re? You must be knowing the length of the arc of the formula. ఏంటి రా ఫార్ములా? రేడియస్ r ఉంటే సెంట్రల్ యాంగిల్ theta ఉంటే you can simply say, sir, integral dl is equals to length of arc కదా. Yes. What is the formula for length of arc రా? చెప్పండి అందరికి. So sir, b bar is equals to mu naught I divided by 4 pi r squared into length of r is simply r into theta. అదే, this is the length of arc రా. Hey, radius r, angle theta unte length is equals to r into theta. dl. Add all of them. You will ultimately get the length of the arc. Ade kada. R gone ikkada nunchi. What you get re? You are getting mu naught I into theta divided by 4 pi r. Ida. So this is the magnetic field due to the arc of the circle. Now let us take some questions, okay? Let us take some special scenarios ra. Ee arc semicircle unte emaitadi? లేదా వాట్ విల్ హ్యాపెన్ ఇఫ్ ద ఆర్క్ ఇస్ అ కంప్లీట్ సర్కిల్ రా. చూసుకోండి. సో సెమీ సర్కిల్ ఉంటే సార్ థీటాకి వాల్యూ ఇస్ ఈక్వల్స్ టు పై కదా. ఎస్, ఎందుకంటే చూసుకోండి. సో దిస్ ఈజ్ ద సెమీ సర్కిల్ రా. దిస్ ఈజ్ ద సెంటర్, దిస్ ఈజ్ ఫస్ట్ లైన్, దిస్ ఈజ్ సెకండ్ లైన్. అంటే ఈ యాంగిల్ ఈజ్ కమింగ్ అవుట్ టు బి 180 degrees. 180 అంటే పై, ఇదే కదా. ఫార్ములా చెప్పండి ఒకసారి. మ్యూ నాట్ ఐ థీటా బై 4 pi r, ఇదే కదా. ఎస్ సార్, మ్యాగ్నెటిక్ ఫీల్డ్ ఈజ్ ఈక్వల్స్ టు, మ్యాగ్నెటిక్ ఫీల్డ్ V bar ఈజ్ ఈక్వల్స్ టు మ్యూ నాట్ ఐ థీటా డివైడెడ్ బై 4 ఇంటూ పై ఇంటూ ఆర్. థీటా వాల్యూ ఏం సబ్స్టిట్యూట్ చేయాలిరా? యూ కెన్ సింప్లీ సబ్స్టిట్యూట్ సార్ మ్యూ నాట్ ఐ ఇంటూ థీటా వాల్యూ రైట్స్ పై డివైడెడ్ బై 4 pi r, అదే. అంటే పై గాన్, అంటే మ్యాగ్నెటిక్ ఫీల్డ్ అట్ ద సెంటర్ ఆఫ్ ద సెమీ సర్కిల్ ఈజ్ మ్యూ నాట్ ఐ డివైడెడ్ బై 4r, ఇదే కదా. ఎస్. వాట్ అబౌట్ ద కంప్లీట్ సర్కిల్ రా? వాట్ అబౌట్ ద కంప్లీట్ సర్కిల్? గుడ్ మార్నింగ్, గుడ్ మార్నింగ్, గుడ్ మార్నింగ్, గుడ్ మార్నింగ్ లిలీ. కంప్లీట్ సర్కిల్ ఉంటే ఈ థీటాకి వాల్యూ ఇట్ ఈస్ కమింగ్ యాజ్ 2 pi. చూసుకోండి అందరికి. సో ఫార్ములా చెప్పండి ఒకసారి. మ్యాగ్నెటిక్ ఫీల్డ్ B bar ఈజ్ ఈక్వల్స్ టు మ్యూ నాట్ ఐ ఇంటూ థీటా డివైడెడ్ బై 4 pi r. ఇది ఫార్ములా గుర్తుపెట్టుకోండి అందరికి. ఇఫ్ యు ఆర్ నాట్ అండర్స్టాండింగ్ అబౌట్ ద సెమీ సర్కిల్ ఆర్ ఫుల్ సర్కిల్, లేదా యూ డోంట్ వాంట్ టు కీప్ ఆల్ ద ఇన్ఫర్మేషన్, యూ జస్ట్ రిమెంబర్ దిస్ ఫార్ములా, అంతే కదా. ఎస్. సో వాట్ యుల్ గెట్ రా? యూ విల్ సింప్లీ గెట్ మ్యూ నాట్ ఇంటూ ఐ ఇంటూ థీటా వాల్యూ అంటే 2 pi డివైడెడ్ బై 4 pi r, ఇదే కదా. ఎస్. సో ఇది పై గాన్, 2 గాన్, యూ విల్ సింప్లీ గెట్ మ్యూ నాట్ ఐ డివైడెడ్ బై 2r. చూసుకోండి అందరికి. సో దిస్ ఈజ్ ద మ్యాగ్నెటిక్ ఫీల్డ్ అట్ ద సెంటర్ ఆఫ్ ద సర్కిల్. ఇది మీ మ్యాగ్నెటిక్ ఫీల్డ్ అట్ ద సెంటర్ ఆఫ్ అ సెమీ సర్కిల్. రిజల్ట్స్ వచ్చింది కదా. ఎస్, గుడ్, వెరీ గుడ్ జాన్వి, వెరీ గుడ్. నౌ let us talk about coil, circular coil, లేదా I should say magnetic field due to circular coil. Okay, due to circular coil having n turns. చెప్పండి. సో సార్, ఇట్ ఈజ్ మై సర్క్యులర్ కాయిల్, కానీ దేర్ ఆర్ సమ్ టర్న్స్ ఇన్ టు ఇట్. టర్న్స్ ఉంటే ఏమిందిరా? నథింగ్ హ్యాపన్స్ సార్, ఓన్లీ ద వాల్యూ ఆఫ్ కరెంట్ చేంజెస్. అదే, రేడియస్ కూడా సేమ్ ఉంటుంది, యాంగిల్స్ కూడా సేమ్, ఎవ్రీథింగ్ సేమ్. ఓన్లీ ఒకసారి దెర్ వాజ్ అ సింగిల్ వైర్, నౌ దెర్ ఆర్ 2, 3, 4, 5, 6 n వైర్స్ ఉంటుంది, అంటే కరెంట్ విల్ గెట్ మల్టిప్లైడ్ రా. అదే, సో n టర్న్స్ ఉంటే దెర్ ఆర్ n టర్న్స్. చెప్పండి, వాట్ ఈస్ ద magnetic field at the center of a circle? First of all, tell me that mu naught I by 2r, అదే కదా, right. So sir, same magnetic field mu naught into total current I total divided by 2r, అదే. total I అంటే ఎంతరా? in one loop there is I, 2 loops 2i, 3 loops 3i, 4 loops 4i, n loops ni, అంతే కదా. So total magnetic field B bar is equals to mu naught ni divided by 2r. So this is the magnetic field due to the current carrying coil. Okay, some extra information. Okay, this chapter is actually my favorite chapter. Okay, my favorite, the best chapter in physics, I would say it's magnetism. Okay, ఎందుకంటే I can't even express the depths of this chapter. It's a really beautiful one, beautiful. Okay, చూసుకోండి. Now I will tell you 2-3 different ways or analogies how you can understand everything about it. Okay, how you can understand that. చూసుకోండి అందరికి. మ్యాగ్నెటిక్ ఫీల్డ్కి డైరెక్షన్ కావాలి, అంతే కదా. హౌ విల్ యూ ఫైండ్ ద డైరెక్షన్ ఆఫ్ మ్యాగ్నెటిక్ ఫీల్డ్? వన్ వే ఈజ్ టు గో విత్ యువర్ Biot-Savart Law. ఇది కానీ దాట్ మెథడ్ ఈజ్ అ లిటిల్ ట్రికియర్, ఎందుకంటే ఆల్ ద టైమ్స్ యూ ఆర్ హ్యావింగ్ టు ఫైండ్ ద డిఎల్ బార్, దాని తర్వాత ఆర్ బార్ తీసుకోండి, క్రాస్ ప్రొడక్ట్ తీసుకోండి, టూ మచ్ కాంప్లికేషన్స్. ఓకే, ఐఎమ్ టెలింగ్ యూ సమ్ సింపుల్ షార్ట్ కట్స్ రా. చూసుకో, మీ దగ్గర ఒక వైర్ ఉంటే, if this is a current, okay, if you have a wire and you have a current, how will you find the magnetic field at a desired point? Okay, okay, wire and for a circle, they are different approaches. Andariki cheppandi, what I am telling to you all the times remember, ఎప్పుడైనా మీ దగ్గర ఒక వైర్ ఉంటే you take your thumb in the direction of your current, అంటే right hand thumb rule, అదే. So you take your thumb in the direction of the current, okay, and then ఆ తర్వాత what to do చెప్పండి Lily, what to do next? You take your thumb in the direction of current, and then what to do? ఏం చేయాలి? You take your thumb in the direction of current, ఆ తర్వాత right? Okay. And then, hey, why are you silent? You're not speaking anything. Right hand thumb rule, that's it, that's what you're told, right? Chusko. You take your thumb in the direction of current and then you turn your fingers, okay? You turn your fingers. Good, very good, very good. No, not DL. In this saying, it is not gonna be DL. Take your thumb in the direction of current, rotate your fingers, and they are going into the plane kada. Yes, so in the right side of this wire, the magnetic field will be inside ante into the plane of the paper, ante kada. Yes, the magnetic field will be into the plane of the paper andariki. What about the left side ra? From the left side, when you are rotating your fingers, చూసుకోండి అందరికి, rotated, gone inside, now coming outside, అదే కదా. Yes, so in the left side it will come outside of the plane of the paper, అదే అంతే కదా. Yes sir, we knew this right hand rule. What about the loop? In that you can't apply the same rule. For a circular loop you do the reverse అంటే ఏంటిరా? For a circular loop, now you don't take your thumb in the direction of current. What do? You curl your fingers in the direction of current. Right hand, ekkada kuda right hand. Always remember, only the right hand must be used. You take or you rotate your fingers in the direction of the current, and your thumb will give you the direction of the magnetic field. Understanding? Yes. So you rotate your fingers in this direction, and your thumb will give you the direction of the current outside. Ante kada? Yes. What about these points, sir? Sir, outside of the circle kavalante, you have to adopt this method only. Chusko. Only in the center of the circle, this method is valid. Dan tarvata, if you want the magnetic field at these general points, ee kosam you will have to change the directions. Ante entira. Now you have to take the same method. Ante enti, sir? Initially take the direction of thumb. Small length, DL. Small length తీసుకోండి రా అందరికి. Small length DL తీసుకోండి. Again do the same thing. Your thumb in the direction of current, rotate the fingers. Sir, fingers are going in ante outside this circle. ఈ circle కి బయటికి చూసి you will see the magnetic field is into the plane of the paper, ante it is going inside. Okay sir, rotation done and it is coming out of the paper, ante kada. Yes, so here the magnetic field is outside all the times. Andariki చూసుకోండి. In all the circle the magnetic field is outside, కానీ బయటికి వెళ్తే your magnetic field will be inside. Understanding all of you? Something like this. Okay? Good. Leda, even if you don't want to go and understand something like this, okay? You imagine, this is my method, okay? This is my method. And this method will never fail. Sometimes you might get confused here also, sometimes you might get confused there also. But this, my method will never fail, okay? I'm going to tell you a very shortcut. A secret, చెప్పండి. Now you imagine, close your eyes and you imagine that you are going in a train. Train ante enti ra? Train ante open train ra, chusko. So this is the track, okay? Ide mee track ra, okay? And here is the train. Train ante chuskondi ra. This is the four wheels, okay? And this, something like this is your train. Hey, this is the open box of a train. Okay, just understand it. So this is you, Ray. This is you sitting. And here some cave is not. How should I draw the cave, Ray? Cave, the train is going something like this. Can you visualize? You are sitting into the train. And train is going in the straight forward direction. Chuskondi andariki. Leda, I should just do something like this. Chusko. You understand me as you, okay? You understand me as you. You are sitting into the train and there is a cave. Cave ante telusa. This is our cave, okay? This is our cave. Okay? The train has to go into the cave. Andariki చూసుకోండి. The train has to go into the cave. Now visualize, all of you, andariki, all of you. train ante current, train ante current. The track, you can say it is a wire. Andariki chuskondi. Track ante wire, track ante wire, train ante current. Okay, train ante current, track ante wire. Ante you are traveling in the forward direction, ante kada? Yes. Now you see the cave ra, you see the cave. Okay, you see the cave. Clockwise direction telusa? Clockwise ante you imagine there is a clock. All of you, all of you, all of you. What is happening when you are going in a forward direction? I am moving forward and the magnetic field is moving clockwise. When I am going forward, when I am coming backward, magnetic field is moving anti-clockwise. Forward, clockwise. Backward, anti-clockwise. Forward, clockwise. Backward, anti-clockwise. Understanding? So this is something the scene happens with the current also. Whenever the current is flowing forward, for that current, magnetic field will be clockwise. If it is moving forward, leda, if it is coming back, the magnetic field will be anti-clockwise. Hey, are you able to understand? Unable to understand. Chuskondi. I will also give you a hint. Okay, you visualize this is your current flowing in the forward direction. Ante kada? Yes. So, ee current kosam, you see it something like this. It is coming up, Ray. It is coming up. Okay, this is my current. How should I tell you, Ray? There is no pointed thing, something like this. Okay, so you can simply say this is your current. Okay, moving in the upward direction. Yes, I'll tell you once again. Don't worry. Okay, so if this is your current, you understand, Ray, you understand. Okay, so this is our cave, Ra. Where did I write? Gone, right? It should not matter. It should not matter at all. So you imagine it is our cave. Cave ante telusa? The train is to go into this cave ra. Okay, the train has to pass. Train ante me. My back is visible to you, right? Yes. So I am the train. I am the train ante I am the current ray. I am the current. I am the current. You visualize this sir is a current now. Okay. I am the current andariki. So if I am the current and there is this track, emaithe dira? Track ante it is a wire. Okay. Track is a wire and I am a current. Ante when I am going forward, ante current is moving forward, right? So the current is moving forward ante whenever the current is moving forward, chuskondi. Whenever I am moving forward, I will always see the magnetic field lines moving in the clockwise direction. When I am moving in the forward direction. Moving forward, clockwise. Stop, magnetic field also stop. Moving backward, anti-clockwise. Stop, magnetic field also stop. Moving forward, clockwise. Backward, anti-clockwise. Stop, magnetic field also stop. Chuskondi. Understanding, moving forward and it will move always in the clockwise direction. If you understand this, then everything will become piece of cake. You don't need this right hand rule, left hand, nothing. You understand, if the current is moving in the forward direction, it will see magnetic field rotate in the clockwise, something like this. Okay, if it is moving in the forward direction, clockwise. If it is moving in the forward direction, clockwise. Okay, clockwise ante telusa, it's a clockwise, right? Okay, right. If you are not understanding, okay, good. Magnetic field in the clockwise direction. Leda, if it's coming back, then he will see magnetic field in the anti-clockwise when it is coming back. Ade, finished ra, finished. Aa tarvata, if I give you any complex shape, you can easily calculate the magnetic field due to that. Understanding? Chuskondi. If it is my current ra, now you want to think from the current perspective. Ante this is my current moving in the forward direction. Ante kada. So when it is moving in the forward direction, for him, the magnetic field will be clockwise ra. Clockwise ante telusa, something like this. Chuskondi. This is the magnetic field. Ante when it is coming out, upward, chuskondi. Upward, outside, downward, inside. Upward, outside, downward, inside. Upward, outside, downward, inside. Ide kada? You can verify also. Hi Kirtana, hi. Okay, yes. So if you are done with it, we can talk about different shapes. Okay, we can talk about different shapes. Chuskondi. Magnetic field. I. చూసుకోండి, you actually have infinite wire, infinite length wire, and I want you to introduce about finite also so that you can apply it. Find semi-infinite and infinite wire. Okay, I will just tell you for the finite wire, దాని తర్వాత you can apply it for semi-infinite and infinite wire. అందరికి చెప్పండి. So let us say this is my wire ray, current I is flowing, నాకు ఈ పాయింట్ పై magnetic field కావాలి. I want the magnetic field at this point. ఎలా క్యాలిక్యులేట్ చేస్తారు సార్? స్టెప్ నెంబర్ 1, ఫైనైట్ వైర్ ఉంటుంది కదా, స్టెప్ నెంబర్ 1, డ్రా ద నార్మల్. నార్మల్ అంటే ఏంటిరా? పర్పెండిక్యులర్ లైన్. సో ఇదే నా నార్మల్ రా, పర్పెండిక్యులర్ లైన్. ఫినిష్డ్? ఎస్. దాని తర్వాత జాయిన్ ద ఎండ్స్ రా, జాయిన్ ద ఎండ్స్. టాప్ మోస్ట్ బాటమ్ మోస్ట్ ఎండ్ జాయిన్ చేయండి. యూ జాయిన్ దిస్ టాప్ మోస్ట్ ఎండ్, యూ జాయిన్ దిస్ బాటమ్ మోస్ట్ ఎండ్. అండర్స్టాండింగ్? కాల్ ద యాంగిల్ as θ1 and call the angle as θ2. ఇదే కదా? Whenever I am doing such sort of questions, this must be my case. చూసుకోండి, ఫార్ములా ఏంటి సార్? ఫార్ములా is simply equals to mu naught I divided by 4 pi d into sine of θ1 plus sine of θ2. అంతే. So this is the magnetic field due to the wire at a given distance. D ante distance ra, okay? D ante this length of the distance. అదే. So this is the formula for a finite wire. Andariki understanding? All of you understanding or not understanding? Okay, next. So let us convert into semi infinite wire ra. Semi infinite wire ante enti ra? Ante the first end will be fixed. Fixed ante telusa? Fixed ante it is not going to infinity. కానీ the second end will go to infinity. అంటే it is going on till the infinity point. Understanding అందరికి? Right. Let us talk about a general point. అంటే ఈ పాయింట్ పై నాకు magnetic field కావాలి. Do the same steps. Drop a perpendicular on the length. అంటే ఇదే నా perpendicular, అంతే కదా? Yes, this is my perpendicular. Join the ends రా. First end easily join చేయొచ్చు. కానీ the second end is going at infinity, అంటే I will also have to bring the line to join the infinity. అంటే ఇది యాంగిల్ θ2 automatically comes out to be 90 degrees. θ1 remains θ1 only రా, అంతే కదా? Yes. చెప్పు. What will you get? What will you get? చెప్పండి అందరి. You are get sir mu naught I divided by 4 pi into d multiplied by sine of చెప్పండి θ1 plus sine of θ2, అంతే కదా? దిస్ ఇస్ అ ఫార్ములా, గుర్తుపెట్టుకోండి అందరికి. ఇట్స్ అ వెరీ ఇంపార్టెంట్ ఫార్ములా. ఓకే, ఇట్స్ అ వెరీ 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 ఇంపార్టెంట్ ఫార్ములా. సబ్స్టిట్యూట్ ద వాల్యూస్ రా. మ్యాగ్నెటిక్ ఫీల్డ్ B bar is equals to, so B bar is equals to mu naught into I divided by 4 pi into d sine of θ1 is sin θ1 itself, ఎందుకంటే no value θ1 is given కదా, plus sin θ2 అంటే sin 90 రా. sin 90 is 1. You can directly write sin 90 as this. So B bar is equals to mu naught I divided by 4 pi d multiplied by sine of θ1. అర్థమైంది కదా? నెక్స్ట్ యూ రైట్ ద క్వశ్చన్ అందరికి. ఫైండ్ మ్యాగ్నెటిక్ ఫీల్డ్ డ్యూ టు ద వైర్స్ లేదా డ్యూ టు ద కరెంట్ at the given point. Number 1, this is my wire andariki. Okay, let us say the current I is equals to 2 ampere is flowing into it. Okay, I want the magnetic field here ra. ఈ distance అంటే 2 meters తీసుకోండి, and you join the ends, you are getting the angles as θ1 is equals to 30 degrees and θ2 is equals to 30 degrees. First case, చెప్పండి అందరికి. Question number 2. This is my wire. This is the distance 4 meters. Okay. Each and every angle is 45 degrees ra. Okay, and distance current is I is equals to 2 root 2 ampere. 2 root 2 ampere. దాని తర్వాత థర్డ్ సినారియో చెప్పండి అందరికి. థర్డ్ సినారియోలో దిస్ ఈజ్ యువర్ సెమీ ఇన్ఫైనైట్ వైర్ అందరికి. సెమీ ఇన్ఫైనైట్ వైర్లో యూ హ్యావ్ టు ఫైండ్ ద మ్యాగ్నెటిక్ ఫీల్డ్ at this point. A distance d is equals to 5 meters and ఈ యాంగిల్ అంటే this angle theta is equals to 30 degrees and the current value I is equals to 1 ampere. Okay, 3 questions completed. You do 3, then I will have to give 3 more questions to you. Okay, లేదా I'll just take here అందరికి చెప్పండి. Fourth question. This is my semi-infinite wire. Semi అంటే one side it is finite, one side it is infinite. అర్థమైంది? Yes. So this is my wire. Again, I want the magnetic field exactly at this point. ఈ distance తీసుకో. Distance is equals to 10 meters. Current is equals to 2 amperes. చెప్పండి. Okay, you don't tell me in terms of mu naught, you can directly take the value of mu naught. Mu naught is equals to, చెప్పండి అందరికి, 4 pi into 10 to the power minus 7. Take this value, okay, take this value and tell me the answer. I want the answers in all of the cases, okay. I think this lecture will be continuing till 1 p.m. దాని తర్వాత I don't know, okay, after that if you are able to complete it, good, well and fine. If you are not able to complete it, it's okay. You do it, I'll be back, okay. Yes, it will be done, it will be uploaded. Hello. Completed. చెప్పండి అందరికి. So you can simply say in the first question, tell me all of you. First question లో ఇదే నా వైర్ కదా, yes. So these were the two angles. The first angle that was coming as 30 degrees and the second angle was also 30 degrees. The value of current ఎంత ఇచ్చారా? Current is 2 amperes కదా, yes. So the value of the current I is equals to 2 amperes. చెప్పండి అందరికి. Length value also matters కదా. So distance 2 meters తీసుకోండిరా. ఈ distance అంటే 2 meters. అంతే కదా. ఫార్ములా చెప్పండి. B is equals to mu naught I divided by 4 pi d into sin of theta 1 plus sin of theta 2. ఇదే కదా, yes. Substitute mu naught value 4 pi into 10 to the power minus 7 into I value current అంటే 2 ampere divided by 4 into pi into D value is also 2 అదే కదా 4 pi 2 gone రా sin theta 1 అంటే sin 30 half plus sin theta 2 అంటే sin 30 ఇది కూడా half రా half and half becomes 1 అంటే the final answer is 10 to the power minus 7 Tesla. Hey, unit of magnetic field is Tesla. We will discuss everything, okay? We will discuss everything. Very good, Lily, very good, very good. 10 to the power minus 7. Good. Second case lo, you have 45 degree 2 root 2 ampere kada. Yes. So, the current is 2 root 2 ampere and the values are, hey, where is it going? Where is it getting lost? Yes. So, the values are 45 degrees and 45 degrees. Ide kada? Yes. So, ఇది 45 degrees and ఇది కూడా 45 degrees. Perfect. Okay, yes. Sir, what about distance? Distance is 4 meters. Ra. Distance D is equals to 4 meters. Cheppandi, formula cheppandi. I want you to remember this formula. Okay, it's a very important. Right? I don't say with so much of inner requests. Remember, good petkondi. It's very important. Chala important formula. Okay. What is the current value? What is the doubt? Re? What is the doubt? Cheppu. What is the doubt? Don't waste the time andariki. Okay, I don't have much time to talk. Chusko. Formula cheppandi andariki. B bar is equals to formula malli okkasari mu naught I divided by 4 pi d into sin of theta 1 plus sin of theta 2 whole substitute mu naught value 4 pi into 10 to the power minus 7 multiplied by I ante current value entira. You are saying something, Bhargav, what is your doubt? You are not telling, okay, so you are just wasting the time. Choose go. Substitute divided by 4 pi into D. Distance value enta icharu 4. I value current enta ra 2 root 2 ide kada. Yes, multiplied by sin theta 1 ante sin 45 ante 1 by root 2 plus sin theta 2 ante again 1 by root 2. 1 by root 2 plus 1 by root 2 ante 2 by root 2 ante kada. 4 pi gone. Chuskondi. So it is 10 to the power minus 7 into 2 root 2 divided by 4 multiplied by 1 by root 2 plus 1 by root 2 ante 2 by root 2 ide kada. ఎక్కడ నుంచి రూట్ టూ కూడా గాన్ రా 2 2s are 4 కూడా గాన్ యువర్ అగైన్ ఆన్సర్ ఈస్ కమింగ్ యాజ్ మ్యాగ్నెటిక్ ఫీల్డ్ ఇస్ 10 to the power minus 7 Tesla. ఓకే ఎస్ గుడ్ కరెంట్ వాల్యూ ఈజ్ 2 amperes రైట్. యా నెక్స్ట్ క్వశ్చన్ చెప్పండి అందరికి. సో థర్డ్ సిన్లో యూ ఆర్ హ్యావింగ్ ఎన్ సెమీ ఇన్ఫైనైట్ వైర్ యాంగిల్ ఈస్ 30 degrees D 5 meter 1 ampere 5 meter 30 degrees. ఓకే సో ఇదేనా సెమీ ఇన్ఫైనైట్ వైర్ రా. దిస్ డిస్టెన్స్ ఈజ్ 5 meters. ఓకే యాంగిల్ ఈజ్ 30 degrees. కరెంట్ వాల్యూ ఎంత 1 ampere కదా. ఎస్ కరెంట్ ఈజ్ 1 ampere. సో ఇది నా 1 ampere వాల్యూ. You are talking about the value ra kani direction kuda gurtundali. You are understanding, you must also remember the directions whatever the direction is coming. Good morning Leela. Yeah, good morning 1 ampere current cheppo formulas cheppo mu naught I divided by 4 into pi into D into sin of theta 1 plus sin theta 2 ade kada. You remember this formula directly ra andariki. Okay, so that you, and remember D is the perpendicular distance. Perpendicular ante telusa, this is a perpendicular distance. If I am giving you wire somewhere else, a point somewhere else, then also you must be able to draw only that perpendicular distance ra. Okay, good. Cheppandi formula enta sir 4 pi into 10 to the power minus 7. Current is 1 ampere divided by 4 pi into distance enta ra. Distance is 5 meters kada. Yes, sin theta is 1 by 2 plus sin theta 2 ra. Sin theta 2 is 90 degrees. Cheppandi. Sin theta 2 is 1. Right? Yes. 4 pi gone. Sir, it is coming as 10 to the power minus 7 divided by 5 into 3 by 2. Ide kada. Yes. సో 3 ఇంటూ 10 టు ద పవర్ -2 డివైడెడ్ బై 10 అంటే 3 ఇంటూ 10 టు ద పవర్ -3 టెస్లా. సో ఇదే నా మ్యాగ్నెటిక్ ఫీల్డ్ బి. తెలుసా? గుడ్, వెరీ గుడ్, వెరీ గుడ్, వెరీ గుడ్. నాట్ 5, ఇట్ షుడ్ బి 3 ఇంటూ 10 టు ద పవర్ -3. Am I doing some mistake? No, I am not doing any mistake. Cheppandi. Next, let us talk about magnetic field due to infinite wire ra. Infinite wire ante enti ra? It is extending infinitely upward also and downward also. Ante kada? Yes. Naku ee point pai magnetic field kavalante you draw the perpendicular. It is my first step all the times. All the times. And then you take the angles, join the ends ante the first it will be going upwards, it is also going downwards. Ante theta 1 kuda 90 degrees vastundi, theta 2 kuda 90 degrees vastundi. Ade kada? Yes. Cheppandi, formula enti ra? Magnetic field is equals to mu naught I divided by 4 pi d into sin of theta 1. Sin theta 1 ante sin 90 plus malli sin theta 1 ante again it is sin theta 90. Ade kada? Yes sir. So it is mu naught I by simple form, simple. Mu naught I by 2 pi d, mu naught I by 2 pi d, mu naught I by 2 pi d. Are you able to visualize something ra? Mu naught I by 2 pi d ante can you think something? Okay, I am not uploading the notes on Telegram endukante they are not allowing me to send the notes on Telegram. Kabatti I told them to upload the notes in the description section only. Description section only ra. Tell me. So now let us take the collection of all of the formulas, okay? So it is my semicircular arc. This angle is coming out as 120 degrees, okay? Current I is equals to 2 ampere, radius r is equals to 2 meters. First case. దాని తర్వాత సెకండ్ కేస్ గురించి మాట్లాడతాం అందరికి. చెప్పండి. So it is my semicircular arc ra. So this is the direction of current I is equals to 4 amperes now. Center of the circle, first radius, second radius, angle ante pi, theta is equals to pi. Ide kada? Yes. Radius r is equals to 2 meters తీసుకోండి. Next, should I combine and give you all of that? Should I combine it? Andariki cheppandi okasari. Yes, I will combine it, don't worry. So sir, this is my first wire, ide na second wire. Sir, infinite ante telusa? Yes, so these are the infinite wires ra. Okay? Yes, so let me just, yeah, so ikkada nunchi it is starting as a semicircle. Okay, semicircle ra, chusko. This is the center of the semicircle, okay? Idi center ante ide. So this radius r is equals to 4 meters. Andariki cheppandi. And let us say the current is flowing into this direction. I is equals to 4 ampere. Cheppandi. Magnetic field at the center. Center. So I am writing the magnetic field here. Naku magnetic field kavali. Ee point lo. Here also and here also. Cheppandi andariki. Magnetic fields ki values ra. You can combine and you can form n number of questions. Okay, but I am not going into the deep details. Anyway, all of it's for JEE, not for me. Next. Cheppandi, I'll give you some time for that. Yeah. Leela, I will make sure the notes are uploaded. నా దగ్గర ఉంటుంది మొత్తం notes are there with me. Okay, if possible I'll send them. Yeah. చూద్దాం అందరికి one by one చూద్దాం and for all the cases. Okay, so this is my first section. Angle అంటే 120 degrees కదా. Yes, so angle is 120. 120 అంటే you must be able to convert it into the radians. ఎలా కన్వర్ట్ చేయాలి సార్? pi by 180 తోనే మల్టిప్లై చేసుకోండి. Multiply it with pi by 180 అందరికి. So theta is equals to 120 into pi by 180. This is a shortcut ra. So అంటే 2 pi by 3 ఇదే కదా. Yes. Formula గుర్తుందా సార్? Magnetic field B is equals to mu naught I into theta divided by 4 pi r. This is the formula ray. If you are remembering the formulas, that's more than sufficient. Okay, I don't expect you to remember the results also, everything. Just remember the formulas. Ade. Okay, just remember the formulas. Ante. Yeah, Leeladhar, I am telling to you only. Leeladhar, I will let it updated. Okay, I will send the notes. I will have a detailed discussion about the notes and dan tarvata I will take a step. చెప్పండి mu naught వాల్యూ అంటే 4 pi into 10 to the power minus 7. కరెంట్ వాల్యూ ఎంత ఇచ్చారు? కరెంట్ ఇస్ 2 amperes అదే కదా. రేడియస్ ఇస్ 2 meters డివైడెడ్ బై 4 pi. రేడియస్ కూడా 2 కదా. ఎస్. థీటా వాల్యూ ఎంత? 2 pi by 3. 2 gone, 4 pi gone. So it is coming, pi కూడా gone, right? So it is coming as 2 by 3 into 10 to the power minus 7 Tesla. So ఇదే నా మ్యాగ్నెటిక్ ఫీల్డ్ B వచ్చింది కదా. Not 10 to the power minus 7, right? Not 10 to the power minus 7. 2 by 3 into 10 to the power minus 7. Second case లో it's a semicircle కాబట్టి you can directly apply magnetic field B is equals to mu naught I divided by 4r రా. అదే mu naught అంటే 4 pi into 10 to the power minus 7. కరెంట్ వాల్యూ ఎంత సార్? 4 డివైడెడ్ బై 4 ఇంటూ ఆర్ వాల్యూ ఎంతరా? ఇట్ ఈస్ 2 ఇదే కదా. సో 4 గాన్ ఇదే కదా. ఎస్. సో ఇట్ ఈస్ కమింగ్ యాజ్ 2 pi. ఇట్ ఈస్ కమింగ్ యాజ్ 2 pi ఇంటూ 10 to the power minus 7 టెస్లా. సో ఇదే నా మ్యాగ్నెటిక్ ఫీల్డ్ B. చెప్పండి. హియర్ ఇట్ హ్యాస్ బీన్ ఫార్మ్డ్ డ్యూ టు 3 different sections. All the times you understand, okay? All the times you must find the direction. ఎందుకంటే there are 3 different elements రా. ఫస్ట్ ఎలిమెంట్ అంటే ఇది సెమీ సర్కిల్ చూసుకోండి. ఇదే నా ఫస్ట్ ఎలిమెంట్. దాని తర్వాత దిస్ ఈజ్ మై సెకండ్ ఎలిమెంట్ అంటే ఇన్ సెమీ ఇన్ఫైనైట్ వైర్. ఇట్ ఈస్ మై థర్డ్ ఎలిమెంట్ అంటే ఇది కూడా ఒక సెమీ ఇన్ఫైనైట్ వైర్ అదే కదా. ఎస్. సో ఈ మూడు వల్ల యూ హ్యావ్ టు క్యాల్కులేట్ ఆర్ యూ హ్యావ్ టు చెక్ the direction of magnetic field at the center. Sir, ela check cheyali? You have the ideas kada. Yes. So the current is flowing like this. Hey, tell me, magnetic field inside, e side lo magnetic field outside. Are you understanding? Below this wire at all the points magnetic field is outside due to this wire. Okay. Sir, current is going like this and it is coming like this and going like this. E wire wala tell me the magnetic field. Sir, here also it is creating an outside magnetic field and about this semicircle ra, rotate your fingers. It is also creating outside. Ante the direction of each and every magnetic field is same. So you can definitely go and tell the magnetic field. Ante kada? Yes. So the magnetic field is coming outside and you can directly add due to all 3. Ade kada? So magnetic field total is equals to magnetic field due to semicircle plus magnetic field due to wire number 1 plus magnetic field due to wire number 2. Ide kada? Yes. Why am I adding, sir? Because the directions are same. Directions same kakunda you cannot add them. Understanding? Good. Anti-clockwise outside. Very good. So magnetic field due to semicircle enta sir? Formula is mu naught I by 4r plus magnetic field due to semicircular semi-infinite wire ra. Adi kuda angle chusko. It is also 0 degrees. Ante kada? Here also for this wire the angle is 0 degrees ra. 0 degrees. 0. So the formula directly is mu naught I divided by 4 pi r ప్లస్ మళ్ళీ ఒక్కసారి mu naught I divided by 4 pi r. r ఎందుకు రాస్తున్నారంటే ద డిస్టెన్స్ ఇస్ r అంతే కదా. ద డిస్టెన్స్ ఆఫ్ ద పాయింట్ ఫ్రమ్ ద వైర్ ఇస్ d. d వాల్యూ ఇస్ r ఓన్లీ. సో యూ కెన్ డూ వన్ థింగ్, టేక్ mu naught by 4r కామన్ రా. ఇదే కదా. mu naught I by 4r కామన్ తీసుకోండి అండ్ యు ఆర్ లెఫ్ట్ విత్ 1 ప్లస్ 2 by pi. ఇదే కదా. ఎస్. సో mu naught వాల్యూ ఏంటి రా? 4 pi 10 to the power minus 7 current value anta vachindi 4 divided by 4 into radius value antara 4 ikkada kuda 4 4 4 4 gone re. So your answer is simply equal to cheppandi andariki. So your answer is pi into 10 to the power minus 7. Where should I write? I'll write here pi into 10 to the power minus 7 into 1 plus 2 by pi ide kada. ఈ టర్మ్ని సింప్లిఫై చేసుకోండి అందరికి. సో ఇట్ ఈస్ పై ఇంటూ 10 to the power minus 7 మల్టీప్లైడ్ బై పై ప్లస్ 2 by pi ఇదే కదా. ఎస్, సో పై ప్లస్ 2 హోల్ డివైడెడ్ బై పై. సో ఈ పై గెట్స్ క్యాన్సల్డ్. సో యువర్ ఆన్సర్ ఈస్ పై ప్లస్ 2 ఇంటూ 10 to the power minus 7 టెస్లా. చూసుకోండి. సో దిస్ ఈస్ ద వాల్యూ ఆఫ్ ద మ్యాగ్నెటిక్ ఫీల్డ్. అర్థమైంది అందరికీ? ఓకే, రైట్. నెక్స్ట్ సో let me just give you a little tricky question, okay? Then tarvata let us just go and find the other things. So this is my first infinite wire, semi infinite, okay? Semi infinite ante chuskondi. This is the semi infinite wire, okay? So this is a semicircle. So let me draw it with a different color so that you understand. Idi my semicircle, ante kada. Yes, what I'm doing now is I'm applying a battery, not battery actually I should say. I am giving a current. How am I giving the current supply ante? This is a current that is going like this. Chuskodi andariki. Are you understanding? Yes. So sir, current I is here. I is equals to 4 ampere. Ee 4 ampere nunchi some is going like this, some is going like this. So let us say sir 1 ampere is going in the right side and remaining 3 ampere is going in the left side. A system okay, radius I did not give, right? Yes, so radius r is equals to 4 meters ra. Okay, ekkada kuda the radius r is equals to 4 meters. Calculate cheskondi ee point lo magnetic field due to the system. It's a little tricky question. You'll understand it, but anyhow cheppandi. Tell me the magnetic fields. Okay, చూద్దాం. So there are two different values of current kada. Yes, the first current is flowing to the right. Ante ee current, due to this current, where do you think the direction of magnetic field will be at this point? Cheppandi andariki. So the direction of magnetic field at this point will be outside, ante kada. Yes, so the magnetic field will be outside at this point. So ante wire number 1 magnetic field is outside. What about the second current? Cheppandi andariki. Second current is flowing something like this ra, something like this. So due to this current the magnetic field is inside. Understanding? Magnetic field is inside due to this current. And what about this current ra? Idi kuda chuskondi andariki. Magnetic field is inside. Ante due to the semicircle and due to the wire number 1, idi na wire number 2 kada. Yes, the magnetic fields are inside and wire number 2 magnetic field is outside. So ante you cannot add all three together ra. You first will have to add the semicircular field and the wire 1 field. Dan tarvata you have to subtract wire 2 field. Ade. How will you do it? Sir, total magnetic field is equals to magnetic field due to semicircle plus magnetic field due to wire 1 minus magnetic field due to wire 2. Ide kada. Semicircle magnetic field cheppadi. What is the formula ra? Sir, mu naught I divided by 4r plus due to this wire. సార్ మ్యూ నాట్ ఐ డివైడెడ్ బై ఐ అంటే I1 తీసుకోండి, I1 I2 రెండు వేరే వాల్యూస్ ఉంటుంది కదా. ఎస్, సో ఇది నా I1 వాల్యూ రా. I1 అంటే 3 ఆంపియర్, I2 అంటే 1 ఆంపియర్, డివైడెడ్ బై 4 ఇంటూ పై ఇంటూ ఆర్ మైనస్ మ్యూ నాట్ ఇంటూ I2 డివైడెడ్ బై 4 ఇంటూ పై ఇంటూ ఆర్, ఇదే కదా. ఎస్, వాట్ క్యాన్ యూ టేక్ కామన్ సార్? సార్ ఐ కెన్ టేక్ మ్యూ నాట్ డివైడెడ్ బై 4r యాజ్ కామన్. వాట్ ఈస్ లెఫ్ట్ రా? I1 ప్లస్ I1 బై పై మైనస్ I2 బై పై, ఇదే కదా. సింప్లిఫై చేసుకోండి, చెప్పండి వాల్యూస్. మ్యూ నాట్ వాల్యూ ఇస్ 4 పై ఇంటూ 10 టు ద పవర్ మైనస్ 7 డివైడెడ్ బై 4r, అంతే కదా. ఆర్ వాల్యూ ఎంత ఇచ్చారు? ఇట్ ఈస్ ఆల్సో 4 మల్టిప్లైడ్ బై I1 వాల్యూ ఎంతరా? I1 అంటే 3, I2 అంటే 1. సో I1 వాల్యూ ఇస్ 3 ప్లస్ 3 బై పై మైనస్ 1 బై పై, ఇదే కదా. చూసుకోండి, చెక్ చేసుకోండి ఒకసారి ఇఫ్ యు నాట్ అండర్స్టాండ్. Because Lily, you see magnetic field due to wire 2 at this point. Then wire 2 ante direction of the current is in the right side. That's what I'm telling. The current is not flowing in the same direction. In this wire, the current is towards the right. Kani ee upper system lo the current is in the opposite directions. Ante kada. That's why I gave you. Chusko. The current is coming like this and getting distributed into two different branches. Coming like this, distributed into two different branches. Ante ee wire valla the magnetic field at this point డైరెక్షన్ చెక్ చేసుకోండి ఒకసారి. సో ఇట్ ఈస్ కమింగ్ అవుట్ సైడ్ కదా. ఎస్, ద మ్యాగ్నెటిక్ ఫీల్డ్ డ్యూ టు ద సెకండ్ వైర్ ఈజ్ అవుట్ సైడ్. కానీ మ్యాగ్నెటిక్ ఫీల్డ్ డ్యూ టు ద ఫస్ట్ వైర్ రా, ఇట్ ఈస్ ఇన్సైడ్ ద ప్లేన్. అండ్ మ్యాగ్నెటిక్ ఫీల్డ్ డ్యూ టు ద సెమీ సర్కిల్, ఇట్ ఈస్ ఆల్సో ఇన్సైడ్ ద ప్లేన్ కదా. సో ద డైరెక్షన్స్ ఆర్ ఆపోజిట్, కాబట్టి నెగటివ్ వస్తుంది. ఓకే, finished. So sir, 4 gone. Sir, pi by 4 into 10 to the power minus 7 divided by 3 plus 2 by pi kada. Yes, so pi by 4 10 to the power minus 7 into 3 pi plus 2 divided by pi. Pi gone ra, ante 3 pi చూసుకోండి, అంటే 3 pi plus 2 divided by 4 into 10 to the power minus 7. Right, Tesla. So this is my magnetic field B. Final answer తీసుకోండి, ఇది మీ ఫైనల్ ఆన్సర్ అందరికి. ఓకే, what is the time now? 10:54 కదా. Yes, so let us take a break, all of you. Okay, let us take a break. Okay, if energy lost, go eat something and come with more energy. So ఇది your break రా. టైమింగ్ ఎంత సార్? 11 నుంచి 11:25. Okay, after break what we will be discussing? Solenoid, magnetic field due to solenoid. దాని తర్వాత apparatus అంటే ఏంటి సార్? apparatus అంటే cyclotron. ఓకే, దాని తర్వాత velocity selector. And then we'll talk about Ampere circuital law. Some PYQs, if possible PYQs also, and then we'll be discussing the rest of the chapter. Okay, rest of the chapter. I don't think it will be completed in today's class. We have to end it at 1 p.m. anyhow. Okay, take a break and we'll come back at 11:25. Hi, 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 hi. Hello, hello, hello. Done, done with the break. Okay, sir. There are some PYQs actually. If you want, I can take that also. Okay, let us discuss some PYQs, sir. Okay. Is it not coming right? చెప్పండి. హాయ్ ఇషా, హాయ్ 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 హాయ్. చెప్పండి అందరికి. So, you can simply say that the magnitude of the magnetic field is given by hi Kanmani hi Vaishu hi What? I'm feeling little. చెప్పండి ఫార్ములా ఏంటిరా? ఫార్ములా ఇస్ ఈక్వల్స్ టు ఇప్పుడు చెప్పిన కదా మ్యూ నాట్ ఎన్ ఐ డివైడెడ్ బై 2r. అదే చెప్పండి రా. మ్యూ నాట్ వాల్యూ ఇస్ 4 pi into 10 to the power minus 7. How many turns are there రా? Turns are, current is 7 ampere and 100 turns kada. Yes, so 100 turns multiplied by 7 ampere current divided by 2 into radius ఎంత రా? Radius is 10 centimeter అంటే 0.1 meters, right? Yes, 0.1. SI యూనిట్స్ ఉండాలి అందరికీ. చెప్పండి. క్యాల్కులేట్ చేసుకోండి. టెల్ మీ ద ఆన్సర్ ఆఫ్టర్ క్యాల్కులేషన్స్. It can't be that, right? Can't be that. So 2 gone. So it is a pi value 22/7. అంతే కదా? Yes. Two ones are 2, 2 twos are 4, so 2 pi into 7 into 10 to the power minus 7 into 100 divided by 0.1. 2 pi ante enda 2 into 22 by 7 into 7 into 10 to the power 2 here, and 1 comes up until it becomes 10 to the power minus 7 into 10 to the power 3. Ade kada? Yes. So you can simply say that is equals to how much? 7 gone ante 44 into 10 to the power minus 4 Tesla. Ide kada? So you can also simplify it something like this as 4.4 to 10 to the power minus 3 Tesla. Minus 3 ante millitesla ante 4.4 millitesla. Okay, next. See, if you are done with these questions, then there is nothing in PYQs, okay? Shapura. Having some doubts? Keep asking. Okay, next question, this one. It has been asked in 2024 also. Yeah, 2024 or 2023. Naku teliyadura. App is showing some bugs. What are the bugs? 2023 actually. So the diagram is something like this. Okay, NEET 2023 question. Okay, level should be something like this, and it is coming back from this point. Oy. Infinite ra. Infinite ante telusa. Yes. Too much of bugs and errors, you know. Okay. Infinite is this. A very long conducting wire is bent in a semicircular shape from A to B. Magnetic field at point P. P ante point P is here, all of you. Here is the point P. Radius is R. Teeskondi. Okay. Yes. Option A teesko. You don't have to do the calculations, Andariki. If you are smart enough, you don't have to calculate all the calculations. You can do it directly. How to do it, Ra? Choose Kondi. It is NEET 2023, Andariki. 23. Okay, how will you do it? ఎలా చేయాలి? You understand first. There are 3 different parts. అదే కదా 3 parts ఉన్నాయిరా. First part is your wire, దాని తర్వాత your semicircular and then again a wire. So the magnetic field given in the option B and option D, it is only for a semicircular wire. అదే కదా mu naught I by 4r అంటే semicircular wire కోసం only. But I have 2 more. I have two more. అంటే this will be gone. This cannot be the answer. This also cannot be the answer. Finished. ఇప్పుడు these are the 2 options. అంతే కదా, you have to analyze, that's it. You only have to analyze. చూసుకో, ఈ wire, it is going in the right side. Current in this wire is actually moving in the right side. So the magnetic field at the point, direction ఏమొస్తుందిరా, direction will be in the inside of the plane. అంతే కదా, yes. See, similarly for this wire also, magnetic field is inside. The only thing is that the semicircle. So due to this semicircle, the magnetic field is coming outside. Ante kada? Yes. Now, 2 wires inside, semicircular, outside. You just write the magnetic field due to a semi-infinite wire. What is the formula? Mu naught I by 4 pi d. 2 times, ఎందుకంటే both are inside kada, so they are in the inside, minus చెప్పండి mu naught I by 4r, అదే it is in the outside direction. అదే కదా, yes, it is inside, it is outside. అంటే whichever is bigger, that value will be calculated as your dominating direction. So mu naught I by 4r bigger or mu naught I by 4 pi d bigger. Which is bigger, sir? Which is bigger? So you'll have to do it. So sir, let us do one thing. Let us take out d. D value ante same ra, r. So sir, 2 times of mu naught I divided by 4 pi r minus mu naught I divided by 4r. Ide kada? Yes. Take out mu naught I by 4r common. Okay, what you are left with is 2 by pi minus 1. 2 by pi minus 1. 2 minus pi, cross multiplication. 2 minus pi. Pi value untara. Pi value is 3.14. 2 minus 3.14 is minus 1.14. Ante it's negative. Negative ante entira. So whatever we are taking, ante this is negative. So if I am telling this is a bigger value, this is a smaller value, their subtraction is coming negative. Ante this is big and this is small. This is big and this is small. Ante the wire, semicircular wire, has more magnetic field than the 2 wires. Ante dominating nature will be outside ra. Ide. Okay, this is the dominating nature. Chuskondi andariki. Understanding. Now we will talk about the directions of magnetic fields also. Okay. Good, very good. Go not very good. Okay, so if I have a loop, circular loop, andariki chudandi. You are late, right? Go not, you are late. Circular loop ante this is my circular loop ra, andariki chuskondi. Okay, circular loop unte the direction of magnetic field chuskondi andariki. So if this is my wire, all of you andariki chuskondi. So this is my wire. Why the color is not showing properly? Is it perfect white? Yes, it's a white, but I can't say as white on this screen, you know. Okay, చూసుకోండి. So this is my loop. తెలుసా కదా? Yes. So due to the loop, magnetic field direction ఏంటిరా? If the current is flowing in this direction, current I, and here also the current is flowing in this direction, current I. What about the direction of magnetic fields? అందరికి చెప్పండి. Sir, if the current is I, ante the magnetic field will be something like this. Can you visualize ra? At this point. And at this point, the magnetic field direction, direction also write it. Okay, raskondi. Direction will be something like this. Magnetic field ki direction at each and every point andariki. Inside. So this is the magnetic field direction. Ekkada kuda the same thing ra. Current flows something like this. Ante when it's in the downward direction, when it is in the downward direction, it is going into the plane. into the plane, into the plane, coming out, coming out, coming out, something like this. Chuskondi. Now, when the current is like this, magnetic field lines will be something like this. Okay, current is like this until it will be going downwards, 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 up, 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 and up. Other. And at the same time, here also 1, 2, 3, 4. There are infinite lines, okay, infinite lines. Cheppandi. So if the current is coming like this, so the magnetic field lines here will be downwards, 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 up, 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 ante. So this is the direction due to a circular loop. Ardhamaindi. Next, let us talk about a wire. Okay, let us talk about a normal wire. So if this is my normal wire and the current is flowing in the vertically upward direction, Cheppandi, what will be the direction of the magnetic field lines? So this is first line, second line, third line, fourth line, fifth line. Ante kada. At each and every single point you will be seeing such magnetic lines. Okay, nice. So it will go and come out until this, come out this, come out this, come out this, go in this, inside this, inside this, inside this, inside this, and coming out into this. Okay, so these are the directions of a magnetic field. Now let us talk about magnetic field on the axis of a ring. Choose kondi. Not question, it should be formula. Magnetic field so if this is my ring, andarki chuskondi re, all of you. So if this is a ring and this is a current I. But I don't want at the center. Center lo magnetic field enta vastundi sir. So it is mu naught I by 2r. I don't have any problem with that. Okay, I don't have any problem with that. But I don't want it at the center. I want at some random distance. Random distance ante entira. You imagine this is your center and this is the distance. Here. I want the magnetic field at this distance. Cheppandi andariki. What do you think will be the value of the magnetic field at this distance? So you understand some terminologies, okay? First of all, the radius is r and this distance is x. Ante kada? Yes. Magnetic field value, sir, B bar is equals to, you remember the formula, all of you, because it has been asked in one of the PYQs, so I am telling you. To the power 3 by 2. So this is a magnetic field formula. Choose kondi. Okay, chala important ra. What about the directions, sir? What about the directions? Cheppandi. Directions ante this magnetic field current is coming outside and going inside ante it will be away kada? Yes, away. Chuskondi. Ardhamaindi? Okay. Okay. Let us take a PYQ ra. From this also let us take a PYQ. Okay, it has been asked in NEET 2022. Question is magnetic field on the axis of a circular loop. చెప్పండి. Yes, Vaishu, yes, done. What is the answer? C. Yes. Good. చూద్దాం. Okay, Gonat, right. Let us see. I'm fine. Vaishu, I'm fine. Thank you so much for asking. Okay, good. Sir, magnetic field formula on the axis 1 meter long, radius is 100 centimeter. To confuse you, 1 meter ray, అదే 1 meter, radius కూడా 1 meters, r is equals to 1 meters. Current value ఎంత సార్? √2 ampere, అదే కదా సార్. magnetic field is equals to mu naught I r square by x square plus r square to the power 3/2 into 2. చెప్పండి. mu naught value is 4 pi into minus 7. I value is √2. R square అంటే 1 square divided by 2 into x square is 1 square plus r square is 1 square. 3/2 is 3/2. ఇదే కదా. Okay. All right. Substitute and tell me the answer, all of you. So it is coming as 2 ones are 2, 2 twos are 4. అంటే 2 pi ra into 10 to the power minus 7 multiplied by √2 divided by, you see 1 plus 1 to the power 3/2 అంటే 2 to the power 3/2 అంటే 2√2. I'm directly writing 2√2 ఇదే. So gone 2 gone అంటే pi into 10 to the power minus 7 Tesla. Pi value ఏంటిరా? 3.14 into 10 to the power minus 7 Tesla. Good. Now with that being said, I think we can proceed a little further. Okay. Good. Very good. ఓకే సార్, నా దగ్గర ఒక మ్యాగ్నెట్ ఉంటే రెండు పోల్స్ ఉన్నాయి కదా, నార్త్ పోల్ ఆఫ్ ద మ్యాగ్నెట్, సౌత్ పోల్ ఆఫ్ ద మ్యాగ్నెట్. యాజ్ వి ఆల్ నో, magnetic field lines, they start from the north pole and end at the south pole. Ade kada? Yes. Start from the north pole, end at the south pole. Start from the north pole, end at the south pole. Ade ekkada kuda starting. Hey, what? It should be small, right? It should be small, and then I think. Yes, Gonad, you're saying something? Cheppu. So the direction is something like this, Chuskondi. Starting from the north pole, ending at the south pole. Starting from the north pole, ending at the south pole. Starting from the north pole, ending at the south pole. Kani, inside the magnet, andariki, inside the magnet, the scene is reversed. Reversed under starting from the south pole, ending at the north pole. Ante kada, starting from the south pole, చెప్పండి. So starting from the south pole and ending at the north pole. Starting from the south pole, ending at the north pole. Starting from the south pole, ending at the north pole. Ante kada? Yes. You understand, okay? So these are the magnetic field lines into the circle. What did we see, Ray? We seen magnetic field lines. They are existing in loops. Loops kada? Yes. Property number 1 చూసుకోండిరా. Magnetic field lines always exist in loops. ఇదే నా ఫస్ట్ ప్రాపర్టీ రా. దాని తర్వాత ప్రాపర్టీ నెంబర్ 2 తీసుకోండి. మ్యాగ్నెటిక్ ఫీల్డ్ లైన్స్ do not intersect each other. Okay, do not intersect each other. Next, the intensity of magnetic field V bar ade kada is dependent and directly proportional to the number of field lines. Other more properties only. Okay, for you these are more than sufficient. Okay, are you guys saying something, ra? Huh? Okay, fourth one, fourth property. The tangent at the field lines. The tangent at the field lines gives the direction of magnetic field. For example, sir, if I have the magnetic field something like this, okay, point A, point B, Cheppandi, can I simply say magnetic field at A is greater than magnetic field at B? Yes, for sure. Property number 2, ra. So this is my magnetic field. And if I want the direction of magnetic field, you do one thing, ఏదైనా point తీసుకోవచ్చు, you can directly draw a tangent. So this is the direction of magnetic field. అంతే కదా? Yes. So these are all the things about the magnetic fields. Okay, Kanmani, who do you want me to block? You just tell me, I will block them. Okay, you just tell me, I will block them. Chep. Who do you want me to block? 11:54 కదా, yes. Yes, same as electric field. Gonad, same as electric field. The only difference between electric field and magnetic field is that electric field never exists in closed loops. Yeah, there is an exception, induced electric field will exist, కానీ for that we have to study EM waves. మామూలుగా electric field does not exist in closed loops, but magnetic field they always exist in closed loops. Other than this, almost all the characteristics are same. Okay. Good. So ఇప్పుడు let us talk about solenoid. Solenoid అంటే ఏంటి సార్? You take a hollow cylinder, okay, and you wound the wires to it, okay, tons, 1000 turns, 2000 turns, it will become automatically solenoid. Okay, looks something like this. Andariki చూసుకోండి. So ఇదే నా solenoid. It's a cylinder. Not like this. It should be something like this. Solenoid. Okay. Yes. So if you are traveling current I, it will go and all the current I ante n turns చూసుకోండిరా. I'm telling you n turns are there. Ante what you can say, sir, magnetic field at the center, yes, solenoid. Okay. I did not. Just so now let us talk about some different terminologies ra andariki chuskondi. Okay, so if I say that the total length of the solenoid is L, ee L length lo there are total capital N turns ra andariki chuskondi. Capital N turns unnai ra. Ee mottam solenoid lo there are total capital N turns, ade kada. Yes, L ante the length of the solenoid. Okay, n ante the turns in the solenoid. So ikkada nunchi we define a terminology, small n is equals to total number of lengths per unit length. Number of turns per unit length ante small n ra. Okay, so from here you can directly say that the magnetic field at the end of the solenoid, magnetic field B, is given as mu naught into n into I. Proof, sir, proof. Even if I give, will you remember? Not remember, although not there for your syllabus, but understand these terminologies. They are important to understand. Let us move to the next topic of our discussion. Next topic ante Ampere's Circuital law. What does it say, sir? Statement is simple, ra. Statement chala simple. What is the statement? Statement is చెప్పండి, integral of b bar dot dl bar is equals to mu naught into I inside. Statement is very simple, sir, but application is a little difficult. Okay? Application has a little twists into it. You will just by heart that formula, sir. Yeah. If you just by heart that formula, things are not going to work. Choose. Exactly like your Biot-Savart law, you do 3-4 steps. What are the steps? Modatiga, you assume your DL length. Dan tarvata, you take the tail of DL nunchi, you draw the position vector, ante kada, and then you do the cross product to find the direction. Yeah, good. Why should, if you know it, very good. Similarly, for Ampere circuital law, koncham rules, set of rules unnaira. You must be familiar with those rules so that you can apply it and come to the answer. What are the set of rules, sir? Yes. What are the set of rules ante? The first rule is you must consider a two-dimensional loop, not three-dimensional. Gauss law, Ampere circuital law, they look similar. Gauss law, what was the statement? In Gauss law, cheppu andariki. In Gauss law, what did we say? What did we say in Gauss law? We simply said integral, cheppandi, E bar dot dA bar is equals to total charge inside divided by epsilon naught. Ade kada. What we are saying here, sir, B bar dot dl bar is mu naught by I inside. Somewhat something similar ra. Kani chala differences unnai. Good afternoon. Bodhi Dharma, good afternoon. First, in Gauss law, we talk about area. Chusko. But here, we talk about length. Major difference ra. Okay. And this I is in multiplication. Chusko. Ade kada. With mu naught. This I is in multiplication relationship and this Q is in division relationship. Ade kada? Yes, these are the differences. The only differences that you have to understand between your Gauss law and your Ampere circuital. Yes, symmetry also. Symmetry follows. So now when you apply your Ampere circuital law, ACL, I will simply say Ampere circuital law ante ACL. What you must take care, the first thing that you must take care is choosing the length. Aim length, sir, B bar dot DL bar lo, ee DL bar ki value and direction teesipna. Before you take that, you must be good at choosing the direction. How will you choose it? I will give you some set of rules. Rule number 1. Okay, first let us see about the application. So let us imagine I have some wires. Now I can't draw wires on board, right? 2-3 wires are there. Choose. So what I am doing is, let us say the first wire is going into the plane. First wire into the plane. Second wire coming out of the plane, third wire into the plane, fourth wire coming out of the plane, and so on and so forth. Right. So let us imagine this is going into the plane, current is I1 ra. Here it is coming out of the plane, current is I2. Here it is coming out of the plane, chusko. This is also coming out of the plane, current is I3. Ante kada. And here it is going into the plane, current is I4. Naku oka loop kavali ra. Okay. Loop ante enti ra. You can simply say, sir, the loop should look something like this. You can take whatever loop you want. Okay. You can include all of these charges, currents. Leda, you may skip some, you may add some. So it has, let us say, this is I5 outside. Chuskondi andariki. This is I6 outside. Now andariki chuskondi what I am telling to you, all of you. Hey, listen to me very carefully, andariki. Now your magnetic field along this loop only ra. This loop ante telusa. Magnetic field along this loop only could be given as, first of all tell me, first of all my question, andariki chuskondi. This magnetic field at this point, naku ee point lo magnetic field kavali ra, cheppandi. So it is due to all the currents, right? I5, I4, I2, I6, I3, I1. Ade, it is due to all the currents, all the current carrying wires. We take the superposition, right? We take the superposition until we add all of them in the vector form. Add chesin tarvata, we calculate the magnetic fields. But you remember, okay, first statement, hey, not, it should not be minus. First statement, magnetic field at any point is contributed by all, inside is I2, I4. Are you understanding? inside current is I2 and I4. Finished. And I can simply say, sir, B bar dot dl bar is equals to mu naught into I2 minus I4. Finished. Understanding? So this is the application of Ampere's circuital law. Are you understanding, all of you? It's not buffering, right? Why are you spamming, right? Yes. Okay. So there might be some technical glitches. Adjust it. Okay, adjust it. You can't do anything in it. Okay, good. Chuskondi. So let us talk about magnetic field due to a wire along a distance. Ante entira? If I have an infinite current carrying wire, according to your Biot-Savart law, what did we see? Magnetic field is given as mu naught I by 2 pi d. 2 pi d, yes. Magnetic field at any random distance d is given as, cheppandi andariki. Okay, if the current is flowing in the upward direction, I bar, magnetic field is in the inside. Ade kada? Yes. So, ide na magnetic field, B value is equals to mu naught I divided by 2 pi d. Other. What if we apply the same formula? No, not same formula. What if we apply the another rule? Another rule ante Ampere circuital law. Ampere circuital law use chesina tarvata. What do you think will be the answer? So first set of rules you have to understand. Number 1, Ampere circuital law ki rules ra. ACL, Ampere circuital law. Choose a loop that aligns, okay, that aligns with the direction of magnetic field. Point number 1. Ade, this is the most crucial step in your Ampere circuital law. If you are deprived of this, finished. Your entire work is gone, ra. Ante kada? Yes. So you have to understand the most important stuff in your Ampere circuital law is choosing a loop, ra. It must align with the direction of magnetic field. Ippudu cheppandi andariki. What is the direction of magnetic field, sir? It is going in and it is coming out. Ade kada? Yes. So going inside and coming outside. So this is my magnetic field. Ade, this should be your loop also, ra. This should be your loop also. Understanding, all of you? Okay. This should be your loop also. Loop ante telusara? Loop ante, this is the loop in which I am trying to calculate the magnetic field. Cheppandi. What does the formula say? Integral B bar dot dl bar. Hey, this is only for closed, ra. Closed ante telusa. It only means if you are understanding or if you are forgetting, you can't apply your Ampere circuital law for open objects. Open objects ante telusa. No sir, I only want this loop. You can't apply. Even if the current is like this, you can't apply. It's not closed, ra. Understanding? Okay. Is equals to mu naught into I inside. Cheppu andariki. B bar ki direction enti ra? Here it is inside. DL bar same direction. Direction same untundi ra. At each and every point the direction of B bar and DL bar is same. Ade. That is the biggest benefit. You don't have to take plus and minus. Go not, if you are taking the direction of DL in the direction of B bar, you don't have to take plus or minus. It will always be plus. Okay, it will always be plus. And you can simply say B into DL ra is equals to B bar dot DL. B DL cos theta kada. Theta value 0 ostundi. Cos 0 1 ostundi, and automatically it will get cancelled ra. So it becomes mu naught into I inside. I inside enta ra? Ee loop lo inside current enta? I. Ide. So you can simply say that it is equals to I. Cheppu. B ante constant kada. Bayatiki teesko. So you can say, sir, B into closed integral of DL is equals to mu naught into I. Ade kada? Okay. Nice. Okay. So from here, sir, B into add cheskora DL. When you add it, what do you get? Length of the wire, circumference, 2 pi r. Ante 2 pi d ra, radius is d. So sir, 2 pi r ante 2 pi d is the circumference, is equals to mu naught into I. ఎక్కడి నుంచి యువర్ మ్యాగ్నెటిక్ ఫీల్డ్ B is equals to mu naught into I divided by 2 pi d. అదే కదా, యు ఆర్ గెటింగ్ ద సేమ్ రిజల్ట్స్. యూ గో విత్ విచ్ ఎవర్ మెథడ్ యూ వాంట్. అర్థమైంది అందరికీ? చెప్పు. No, go not. It shouldn't. Yeah, I understood your problem. When you are taking plus or minus, take the bigger current as plus, smaller current as minus. Understanding? Bigger current as plus, smaller current as minus. And then, chesina tarvata, you replace the two wires with a single wire. I1 minus I2, single wire. The direction of that wire should be in the bigger direction. Yeah, that's what I'm telling you. So there are some application based questions, Ram. Okay? Yes, did you understand? Did you understand, all of you? So hollow current carrying wire ఉంటే this one. ఇదే కదా, ఇట్స్ అన్ ఇన్ఫైనైట్ వైర్. అందరికీ చూసుకోండి, ఇన్ఫైనైట్ అంటే గోయింగ్ అప్ ఆల్సో, గోయింగ్ డౌన్ ఆల్సో. చూసుకో. అండర్స్టాండింగ్? హాలో కరెంట్ క్యారింగ్ వైర్ అంటే ద కరెంట్ ఈజ్ ఓన్లీ దేర్ along the edges. Edges ante telusa, only there something like this, only on the edges ra, only on the edges. Can you visualize? Yes. So when I see this from the top point of view ante telusa, when I see this from the upper part, what will I see? I will see only a circle. Understanding? I will see only a circle and the current is going inside ra. Inside ante this is my current. Inside ante this is my current. చూసుకోండి అందరికి. This. Can you visualize, all of you? This is your current. Only across the ends. Okay? Only across the ends. Good. So, ఇప్పుడు I have to take the same thing, Ray. If it's a magnetic field అంటే ఒక loop consider చేసుకోండి. So, your distances are something like this. So, this is your center. You keep on increasing the value of the distance. 3 పాయింట్స్ తీసుకున్నారు, చూసుకోండి అందరికి. The first point is the internal point R1 value. దాని తర్వాత the second point is exactly point on the surface R2 value రా. And దాని తర్వాత third point will be something like this. చెప్పండి అందరికి, ఇదేనా థర్డ్ పాయింట్ అంటే R3? లేదా you can randomly say, sir, for R is 0, not 0, equal to 0 to R. R అంటే రేడియస్ ఆఫ్ ద వైర్. రేడియస్ అంటే తెలుసా, ఇది నా డిస్టెన్స్ క్యాపిటల్ R రా. 0 to R అంటే ఇంటర్నల్ పాయింట్స్ ఆఫ్ ద వైర్. ఓకే? సెకండ్ సినారియో, ఫస్ట్ సెకండ్ కేసులో సార్ R is equals to R, అండ్ దాని తర్వాత థర్డ్ కేసులో సార్ R is greater than R. చెప్పండి, హౌ ద సినారియో విల్ చేంజ్. సో ఇన్ ద ఫస్ట్ కేస్ వెన్ ఐ సీ దిస్ ఈజ్ మై వైర్ రా, అండ్ దిస్ ఈజ్ మై ఆంపియర్ లూప్. చూసుకోండి, దిస్ ఈజ్ మై లూప్. ఇదే నా లూప్, అంతే కదా? ఎస్. వాట్ ఈస్ ద ఫార్ములా సార్ ఫర్ లెట్ us say R? R అంటే ఫస్ట్ సినారియో 0 less than R less than R. చెప్పండి, వాట్ ఈస్ ద ఫార్ములా? B bar dot DL bar is equals to mu naught into I inside. I inside అంటే inside loop the current. What is the current inside the loop, sir? 0. Complete 0 current is there in the loop. అంటే you can simply say closed integral of B bar dot DL bar should be equals to 0 ante B into integral DL is equals to 0 ante B is equals to 0. Point number 1 to be noted. సెకండ్ కేసులో చెప్పండి, సెకండ్ కేసులో వెన్ యువర్ ఆర్ ఇస్ ఈక్వల్స్ టు ఆర్ అంటే యూఆర్ టాకింగ్ అబౌట్ ద బౌండరీ కండిషన్స్. ఇప్పుడు అదే కదా, ఎస్. సో ఇదే నా లూప్ అండ్ దిస్ ఈజ్ మై సర్ఫేస్ రా. చెప్పండి అందరికి. సో వాట్ యూ గెట్ రే? అగైన్ అప్లై ద సేమ్ ఫార్ములా. వాట్ ఈస్ ద ఫార్ములా సార్? ఇంటెగ్రల్ b bar dot dl bar is equals to mu naught into I inside. ఎప్పుడు I inside is I only, అంతే కదా, ఎస్. సో b bar is a constant, take it out, dl bar, total integral of dl bar is mu naught into I. Integral dl అంటే length of the circumference రా, 2 pi capital R, 2 pi capital R. సో b into చెప్పండి 2 pi capital R is equals to mu naught I అంటే b is equals to mu naught I by 2 pi capital R. ఇదే మీ థర్డ్ కేసులో వాట్ హ్యాపన్స్ ఇస్, ఇన్ యువర్ థర్డ్ సినారియో వెన్ ఆర్ ఈస్ గ్రేటర్ దెన్ ఆర్ అంటే అవుట్ సైడ్ పాయింట్ కదా, ఎస్. సో లెట్ us imagine some random outside point రా. సో దిస్ ఈజ్ మై లూప్, ఆల్ ఆఫ్ యూ, అండ్ యువర్ కరెంట్ రా, ఓకే, ద కరెంట్ ఈస్ ఫ్లోయింగ్ ఇన్సైడ్ సంథింగ్ లైక్ దిస్, చూసుకోండి. సో దిస్ ఈజ్ యువర్ సిలిండర్, వైర్, hollow wire, and the loop is something like this. This is your loop. Distance is r. చెప్పండి అగైన్ మళ్ళీ ద సేమ్ ఫార్ములా, ఇంటెగ్రల్ b bar dot dl bar is equals to mu naught into I inside. అదే కదా, ఎస్. b constant, so b into integral of dl bar is equals to mu naught into I inside అంటే b into integral dl రా, dl అంటే టోటల్ లెంత్ కదా, 2 pi small r, 2 pi into small r is equals to mu naught into I. ఎక్కడి నుంచి you get b is equals to mu naught I by 2 pi r. R అంటే ద డిస్టెన్స్ ఆఫ్ ద పాయింట్స్ ఫ్రమ్ ద సెంటర్. అర్థమైంది కదా, ఎస్. గ్రాఫ్స్ గురించి మాట్లాడాలంటే ద గ్రాఫ్ లుక్స్ సంథింగ్ లైక్ దిస్, b వర్సెస్ r డిస్టెన్స్. చూసుకో. సో వెన్ ద గ్రాఫ్, వెన్ ద వాల్యూ ఆఫ్ r వాజ్ 0 to r రే, చూసుకోండి ఇదే నా r వాల్యూస్ కదా, ఎస్, ఇదే నా b వాల్యూస్. చెప్పండి అందరికి. సో వెన్ ద ఆర్ వాల్యూ వాజ్ 0 to capital R, నో మ్యాగ్నెటిక్ ఫీల్డ్ అంటే కంప్లీట్ జీరో. దాని తర్వాత సడన్లీ ఇట్ ఇంక్రీజ్ టు mu naught I by 2r. చూసుకోండి. సో ఇట్ ఇంక్రీజ్డ్ టు mu naught I divided by 2 pi r, క్యాపిటల్ R. అండ్ అక్కడ నుంచి యాజ్ ద వాల్యూ ఆఫ్ రేడియస్ ఇస్ డిక్రీజింగ్, మ్యాగ్నెటిక్ ఫీల్డ్ ఇస్ ఆల్సో డిక్రీజింగ్. అర్థమైంది, ఎస్. సేమ్ ఫర్ బోత్, బట్ ఫార్ ద సెకండ్ సినారియో చూసుకో, this is the maximum value of the magnetic field at the edge. R ante capital R, here R ante small r, not same. Capital R is a fixed value, small r could vary, you go away, r, small r increases. So if you go to infinity, then that becomes 0. At infinity it becomes 0, okay, at infinity it becomes 0, but this never becomes 0. Okay, good, great, nice. Hey, do you have for solid wire also ra? Do you have for solid wire also? Solid wire ante enti ra? Solid wire ante this is your solid wire. చూసుకోండి. Solid wire lo your entire current will be flowing through the wire, crossing it. Ante kada, let it flow in the downward direction so that it becomes easy for us to understand. So it is flowing throughout all the points. Can you visualize? Flowing all the points in the downward direction. Yes, good. Yeah, if r is equals to r, then they will become same. They'll become same. If r is equals to capital R, then they will become same. I'm taking it 23, becoming too hot. 24, becoming too cold. Okay, next. Cheppandi. Again I have to see the whole scenario from the top view, okay? From the top view. I actually don't like to explain all of this because I expect the students do it by themselves, okay? Yes, Uzuma. Uzumaki Naruto. ఏం పేర్రా. What a creativity level must be required to keep such names in Japanese dramas also ra. Okay, చూసుకోండి. So if you are looking it from the top view, something like this scenario will be available to me. అంతే కదా. The current is completely going inside. ఇదే gone. So ఇప్పుడు let us talk about current density. గుర్తుందా current density, current electricity లో we discussed that. Current density formula రా. Current density అంటే you assume the total radius to be r. Sir, the current is flowing in the entire area. అంటే current I is flowing in pi r square రా, pi r square. So sir, what can you talk about current density J? J is equals to current upon area, pi r square. Ante kada? Yes. That means in a unit area of the area, this much current is flowing. Choose code. Are you understanding? Good. Very good. Go on. Very good. Yes. So if I want at 3 points, ekkada kuda I am taking the same cases ra. Same cases ante first case lo your R is less than capital R. Second case lo your R is equals to capital R and then your R is greater than capital R. ఇప్పుడు ఒక్కొక్క కేసు డిస్కస్ చేద్దాం అందరికి. సో ఫస్ట్ కేస్ అంటే 0 లెస్ దెన్ ఆర్ లెస్ దెన్ క్యాపిటల్ ఆర్ అంటే ఇంటర్నల్ పాయింట్స్ రా. సో దిస్ ఈజ్ మై వైర్ అందరికి మ్యాగ్నెటిక్ ఫీల్డ్. ఓకే, మ్యాగ్నెటిక్ ఫీల్డ్ చెప్పండి. ఐఎమ్ టేకింగ్ అ లూప్. లూప్ అంటే ఏంటిరా? సో దిస్ ఈజ్ మై లూప్. దిస్ ఈజ్ మై లూప్. రేడియస్ అంటే స్మాల్ ఆర్ వాల్యూ 0 to capital R. అదే కదా? ఎస్. What will be the current in this loop ray? That is my question. Hi Vikshita, hi. What is the value of current in this loop only? In this loop only, sir. Can I simply say, sir, current inside is equals to J into area. Area, J value enta sir? J is equals to, cheppandi andariki, J is equals to I divided by pi into capital R square multiplied by pi into small r square. Ade kada? Pi gone. Sir, inside current is equals to చెప్పండి I into R square divided by R square. You remember, గుర్తుపెట్టుకోండి. It's a very important result అందరికి. So now when you talk about magnetic field at the distance R, you can simply say, sir, how will you find it? Find చేయడానికి you will apply the same formula. B bar dot DL bar is equals to mu naught into I inside. అదే కదా? DL bar ఇంతారా? B bar is a constant entity. Okay, at each and every single point B bar is constant, sir. అంటే టేక్ ఇట్ అవుట్, బయటికి తీసుకోండి. సో యూ కెన్ సింప్లీ సే సార్ బి ఇంటూ క్లోజ్ ఇంటెగ్రల్ ఆఫ్ డిఎల్ బార్ ఇస్ ఈక్వల్స్ టు మ్యూ నాట్ ఇంటూ ఇంటర్నల్ కరెంట్ ఎంత వస్తుందిరా? ఐ ఇంటూ స్మాల్ ఆర్ స్క్వేర్ డివైడెడ్ బై క్యాపిటల్ ఆర్ స్క్వేర్. అదే కదా? ఎస్. సో బి ఇంటూ ఇంటెగ్రల్ డిఎల్ సర్కంఫరెన్స్ టోటల్ లెంత్ ఇస్ 2 pi r. ఎస్. సో బి ఇంటూ 2 pi ఇంటూ స్మాల్ ఆర్ ఇస్ ఈక్వల్స్ టు mu naught I r square by r square. So ఇక్కడ నుంచి you can simply say, sir, B is equals to, where should I write? I should write somewhere here. Chappu. Sir, B is equals to, tell me, all of you, mu naught I r square divided by r square into 2 pi r. Ade kada? Yes, 2 pi r. Simplify cheste, you will get something like this, ra. So you are having B is equals to mu naught I r divided by 2 pi r squared. Ante. Finished? Yes. What about the second point, sir? Second point ante enti ra? Graph chusko, graph chusko, graph. So sir, this is my B, this is my R, and when the value of B versus R kavalante, it is a constant quantity, a constant, and directly proportional to R. You can simply say, sir, B is directly proportional to R. B directly proportional to R unte, your B versus R graph will be something like this. Till R only, okay? R is equals to capital R only, you will get a straight line. దాని తర్వాత ఏమైతుంది? We will see it now, sir. Second case లో let us say the value of R is equals to capital R. Then what will happen, right? చెప్పండి అందరికి. You are saying, you are looking to me. Yes, Gonad center of mass part 2 has been recorded. Okay, the session will be completed by 1 p.m. half an hour more. Anyhow, I have to complete it by 1 p.m. If the chapter is completed, well and good. If not completed, we will take it in the next class. I don't think the chapter will be completed till 1 p.m. ఎందుకంటే we have motion of charge particles, then we have cyclotrons, then we have velocity selector, and after that we have to discuss some other concepts also. Yeah, Gonad. Center of mass part 2 will be available. Don't worry, it has been recorded. It will come soon. But I request all of you to watch that center of mass part 2 with a huge concentration. Okay, I have recorded in a good way. I would not say the best, but I could have done better also. Yes, we will discuss PYQs also. Choose kara. So second scenario lo, your capital R is this. This is your wire, cross section of the wire. Ante kada? Yes. So if it's a cross section of the wire, my loop will be something like this. This is my loop. Ante ఈ loop ki radius is equals to small r ante capital R only ra. Cheppandi. Eppudu you don't have to do anything. Ante the total current inside is equals to I. You don't have to talk about J and all these things. Okay? Yes. So you can simply say, sir, closed integral of b bar dot dl bar is equals to mu naught into I inside. I inside ante I only ra. I only. Nothing. So you can simply say, sir, b bar constant బయటికి తీసుకోండి, b into integral of dl bar is equals to mu naught into I inside. అదే కదా? Yes. dl bar కి ఇంటిగ్రేట్ చేసుకోండి. You will get the total length, circumference 2 pi r. R అంటే capital R. So sir, b into 2 pi capital R is equals to mu naught into I inside is I only ra. So ఇక్కడ నుంచి you can simply say, sir, b is equals to mu naught I divided by 2 pi r. అదే కదా? Yes. What about the third case, sir? Third case lo you can simply say that your R value, it is greater than R. Ade kada? So this is your loop. Ide me wire lo current. And this is your loop. Me loop ante this is the value of R and R is greater than R. Cheppandi. Again the same formula. B bar dot dl bar is equals to mu naught I into I inside. అదే కదా? b bar కాన్స్టెంట్ ఉన్నది బయటికి తీసుకోండి అందరికి. You are left with integral of dl bar. కానీ ఈసారి your dl bar should be 2 pi r only, small r. It is more than capital R. Okay, yes. So you can simply say, sir, mu naught into I. అదే total internal current is I only. So you don't have to talk about the current density and all this stuff. Okay. So you can simply say, sir, b into total length is 2 pi r. చూసుకోండి అందరికి. Is equals to mu naught I. ekkadi nunchi b is equals to mu naught I divided by 2 pi r. Ade. So when you talk about the graphs for solid wire versus hollow wire, graphs gurtupettukondi. It might be asked directly andariki. Solid wire unte the internal magnetic field is directly proportional to the radius for some range ra. చూసుకోండి. This is the magnetic field. దాని తర్వాత it is inversely proportional to R. అదే కదా? Yes. So this is your B value, magnetic field. This is your R value అంటే distance. చూసుకోండి. So this is the point at small r is equals to capital R. అంటే maximum field it will come at the circumference. Circumference అంటే edge of the wire. అదే కదా? Good. Hollow wire unte ra. How will you do it if it's a hollow wire? Hollow wire unte. This is your radius and the distance. This is your magnetic field. Chusko. At a certain range, the value of magnetic field is 0. దాని తర్వాత suddenly it increased and then it is decreasing. అంతే కదా? Yes. Increased value ఏంటి రా? This value is mu naught I divided by 2 pi r. ఇక్కడ కూడా same value ఉంటుంది. చూసుకోండి అందరికి. This value is mu naught I divided by 2 pi into R. Ade kada? Yes. This was all about your Ampere circuital law. Okay. There are a lot of things to discuss in it, but you know it will not be asked. So I'm not. Yes, same as solid, but there is this difference. You know, here and here. Only the internal distances. It's directly proportional. It is 0. Ade. Remaining everything is same. Okay. Good. Do you want me to discuss some PYQs? toroid ante telusu andariki. What is toroid? Yeah, it's good. It's good. Thank you so much. Gonad, thank you so much. You imagine, right? Toroid ante you have a solenoid, okay? You have a solenoid, but you turn into a circle. Okay, you turn that solenoid into a circle ante you have a round shape object, something like this. Chuskondi. Okay, and you are winding the wires to this ante something like this. How should I draw it? I'm not able to understand. Okay, something like this. It will take a little longer time for me to draw, but you understand. Okay, this is your toroid. Are you understanding? I'm winding the wires, Ray. I'm winding the wires to it. Cheppandi andariki. So this is a toroid. Ardhamaindi? Okay. Let us fill some gaps. Something like this. Sir, why are you drawing all this stuff, sir? Is it a drawing class? No. It's a physics class? Yes, it's a physics class. This is a toroid. Ante you are winding it. Okay? Yes. Now current, magnetic field kavali, enter inside a toroid. Ante let us imagine every time the current is I. Ekkada kuda I. Same wire untundi kada? Yes. How many students are watching it? Only 12. Huh? Yes, it's a physics class. It's looking like a donut, right? Huh? Nandini, is it looking like a donut? Well, 33 only, right? 12:33 only. That means we have only spent 3 minutes. Okay. You imagine one thing, andariki. Okay, all of you, I want you to tell one thing. Because you have exam also, right? How many of you have registered for your YSAT exam? And how many of you are giving it? So I think it's at 2 p.m., right? Just an hour later. So you will anyhow get benefited from this lecture. Some questions might come from this lecture also. Okay. Okay. So ఇప్పుడు do one thing. Imagine an Ampere loop. How to imagine an Ampere loop? Let us say this is my Ampere loop. Andariki. Ante kada. Radius is R. Cheppandi. What does the formula say, sir? Closed integral b bar dot dl bar is equals to mu naught into I inside. Ade kada? Yes. dl bar ante enti ra? Total length, circumference 2 pi r. Okay, total length ante 2 pi r. So constant magnetic field బయటికి తీసుకోండి. dl bar is equals to mu naught into inside current ఎంత రా చూసుకో. Inside current అంటే I1 is flowing in. ఇది కూడా I, ఇది కూడా I, ఇది కూడా I. Here also I అంటే if there are n number of turns, capital N. So the total current will be capital N into I. Ade kada? Yes. So you will simply get, sir, B into integral length ante 2 pi into R should be equals to mu naught Ni. Ekkada nunchi you can simply say, sir, B is equals to mu naught Ni divided by 2 pi R. So this is the magnetic field due to a toroid. Oh, okay, Nandini, it's okay. Right, good. So if you want we can go further also, but before that I will see if some PYQs are there or not. You see all the PYQs, okay? I am having confidence. If you have attended this lecture properly, I give you confidence, I give you the guarantee that you will solve all the PYQs at least till this point. Now the topic, Janvi, there is a, you just search for YSAT on Google and apply it. Okay? Just search YSAT for Google and apply it. YSAT ante VAI. Search it and apply. If the date is there today, I don't know, because 3rd was the last date. If its window is still open, if it's still open, very good, go and apply it. Okay, go and apply. Just search it, you will automatically get a link. The registration is free. Appear for the test, online or offline, you can appear wherever you want. Okay, it's a very flexible schedule. Okay, right, perfect. So let us do one thing. Since more, even I don't even have half an hour, right? Yes, sure, Janvi, thank you so much. We don't even have half an hour, so let us do some questions only, Ra. Okay, let us do some questions only. Choose content. Okay, I will ask some difficult questions. Okay, some difficult and a little JEE Mains level questions are there. Not much difficult actually. Second question తీసుకోండి. Okay, Do it. I'm giving you 10 minutes. Then tarvata, let us talk about the answers. Okay, after 10 minutes, we'll be talking about the answers. You can attempt for PYQs also. Okay, you are good to go with the PYQs. Andariki. Okay, for the first one, answer is how much? You can do it. Okay, it's let us see. Okay, let us see. చూద్దాం చలో let us see. Okay, let us see each and every question. ఓకే, రే 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 చూసుకోండి రా. Ray, I was searching a concept, Ray. I was searching a concept, a little higher level concept. Okay, that is about theory of relativity. I was reading it. I was astonished and started smiling. Ra. Don't make other results from it. Okay. Next, చూసుకోండి. So you understand. You understand. If this is my wire, all of you, అందరికి చెప్పండి. If this is my wire, hey, if this is my wire and I want the magnetic field at the given point on the wire only, cheppandi. So I want the magnetic field only on the wire. How will you do it? Not covering it. Ray, it's not like that. You want to see the chat? You see the chat. Useless ra. ఎందుకంటే ఇదే కదా. So anyways, you understood it. You understand it. Okay. The magnetic field on the wire is 0. Always remember, always B bar on the wire is always 0. Now it could be above it లేదా below it. At all the points, if the point is lying on the range of the wire, it will always be 0. అంతే కదా. Yes. So that means the magnetic field due to these two parts, this and this, gone. ఎందుకంటే this point P is lying in the line. అదే కదా. Yes. So I only have to calculate due to this semicircle, current is going like this. చూసుకోండి అందరికి. So this is the current coming up and this is the current. అంటే the magnetic field due to the smaller semicircle is outside and the magnetic field due to the bigger semicircle is inside. అంతే కదా. So the net magnetic field will be the subtraction. అంటే resultant magnetic field is the subtraction of both the magnetic fields. అంటే B net is equals to B1 bar minus B2 bar. ఎందుకు మైనస్ సార్? ఎందుకంటే the directions are opposite రా. చూసుకో, the direction due to the smaller wire, it is coming outside and the magnetic field due to the bigger wire is inside the plane of the paper. అంతే కదా. Yes. So you can simply say B1 value చెప్పండి. సెమీసర్కిల్ ఉంటుంది కదా. సెమీసర్కిల్లో magnetic field is mu naught I by 4r. mu naught I by 4r. So sir, mu naught I divided by 4 into r1. r1 value ఎంతారా? r minus mu naught I divided by 4 into r value is 2r. అదే కదా. Yes. So you can simply say it is equals to mu naught I by 4r minus mu naught I by 8r. అదే కదా. You can take out mu naught I by r common ra. What you are left is 1 by 4 minus 1 by 8. అదే కదా. Yes. So you are left with mu naught I divided by r into 8 minus 4 is 4 divided by 8 4s are 32. అంటే mu naught I by 8r. అదే. So this is my net magnetic field. Okay. It has been asked in JEE mains also multiple times. Okay. It has been asked in JEE mains also multiple times. Okay. $12:50. What is the time? Like how much duration? 3 hours and 30 minutes or 40 minutes? Okay, let's continue till. Let us talk about this question also. Next question. చూసుకోండి అందరికి. But to attempt this question, you must be knowing the lengths of the arcs of the formula. Lengths of the arcs telusa andariki. Lengths of the arcs telusa. You understand. First, total angles are 2 pi. ఈ 2 pi నుంచి 1, 2, 3, 4, 5, 6, 7, 8. 2 pi by 8 అంటే pi by 4 అదే కదా. Yes sir, total angle theta is equals to 2 pi by 8 అంటే pi by 4. Each and every angle is 45 degree into it. Are you understanding? 45 degree angle unte length of the arc ra r into theta kada. Yes, so sir you can simply say sir length of the arc is equals to r into theta ante you talk about the smaller lengths ra. Okay, let me just represent the smaller lengths with a different color. So it is my smaller length, it is my smaller length, it is my smaller length, it is my smaller length ante kada. Yes, 1 2 3 4 4 small circles are there. Cheppandi, can I simply say sir the length of each circle is simply equals to r. R ante entara, r value cheppandi andariki. For smaller circles this is my r value kada. Yes, r ikkada kuda the same value r. And here also I am telling the same value as r ante kada. Yes. What about the bigger circles sir? For the bigger circles you can simply consider this value is 2r 2r. Okay, here also 2r 2r, ikkada kuda here also 2r 2r, circle completed, right? And here also it is 2r and it is 2r, finished. So that means the entire system is consisting of 8 different circles. 8 different circles, ade kada. Yes, entire system is consisting of 8 different arcs ra, 8 different arcs. Deentlochi 4 of the arcs they have the radius 2r and migita 4 they have the radius is equals to r. Sir total length gurinchi cheppalante you can simply say sir length is equals to r into theta. Cheppandi r into theta value enti ra, pi by 4 ade kada. Yes, so this is sir r into pi by 4. చూసుకో అందరికి చూసుకోండి. This is r into pi by 4, r into pi by 4, r into pi by 4, r into pi by 4 అంటే 4r into pi by 4 అంటే r into pi. చూసుకోరా, r into pi అదే కదా. Yes, so this is my total length రే. Now what is the formula for magnetic fields are mu naught I into చెప్పండి అందరికి mu naught I into what should I write? 4r. Why sir? r pi is a semicircle. Yes, with the radius r. So you can simply take it and classify something like this. చూసుకోండి, rearrange. ఎలా rearrange చేస్తారు sir? It became too complicated for now to rearrange all these things. You do one thing, okay? I am writing green, all 4 green wires in one side. 1 2 3 4 semicircle. Immediately pink. చూసుకో, the pink will be pink. I want the field at the center. Understanding? So it's just simply equals to, now you check the direction ra, inside ante the total magnetic field must be added. Ante you can simply say sir mu naught I by 4r plus mu naught I by 8r ade. So you can simply take mu naught I by r common leda 4r common and you are left with 1 plus half ra. 1 plus half ante 3 by 2 into mu naught I divided by 4r ade kada. So you can simply say that is equals to 3 mu naught I divided by 8 into r ade. So this is my entire magnetic field. If you understood, if you don't understand, try it by yourself once again. Okay, even if you are not understanding sir headache aindi ante leave it, not necessary for you to solve all these questions. Okay, yes, the remaining chapter we will be covering it in the next class. Okay, but till that you see you have some gap from here, you have some gap. So till that time I want you to revise all these chapters, especially the chapters current, electricity, capacitors and your magnetism. Magnetism ante magnetic effects of current. Okay, ade endukante your electrodynamics has been completed more than 50%. Now whatever chapter we only have electromagnetic induction, alternating current, that's it. Your entire EMI will be electrodynamics will be completed. Okay, even in your mechanics we are done with your center of mass. So aa tarvata what is remaining is your rotational motion, gravitation, fluid mechanics. Even your mechanics has been completed. So by the end of this month January I will be done with the two major branches ante your electrodynamics and your mechanics, and then we will be focusing on waves, SHM and waves, aa tarvata wave optics, and then geometrical optics, then heat and then your modern physics. Modern physics, I want to cover it just before your exams. Okay, I want you to study modern physics. Okay, study modern physics just before your examinations. Okay, yeah, Gonad will be back soon. Okay, 1 week maybe you will be missing my lectures. After what I will be coming back again. Okay, sure. Good night. Yeah, EM waves will complete. Don't worry, don't worry. EM waves will be in electrodynamics only. It's a small topic, right? It will be done in 1 day. 1 day completed. Yes. After this, we will take classes on Sundays also. Okay. For the entire your examination till NEET, till April. Sundays I will try to cover one shot syllabus. One shot ante small chinna topics ra. Wave of EM waves. Okay. ఆ తర్వాత mechanical properties of solids. And then you have magnetic properties of materials. We will complete it 1 day lecture only. Okay, చాలా theoretical topics ఉన్నాయి దీంట్లో. Good. All right, students. So please take care. Bye bye, and let's meet soon. If you don't have any doubts, can we skip the session? We can. Yes. Okay, bye everybody. Bye, 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 bye. Bye all of you, bye. And yeah, definitely appear for your YSAT exam, okay? I am again reminding all of you, don't miss the examination. Yeah, thank you so much, Gunnar. Bye, bye, bye. All right. Bye, everybody. Bye, 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 bye.